Hello there, and welcome. Tonight, we step into the cold glow of winter, a season that transforms the ordinary into something otherworldly. Snowflakes spiral through lamplight like drifting galaxies. Frozen rivers carry hidden currents beneath glassy surfaces. Animals slow their rhythms to match the stillness, while storms gather strength with almost deliberate grace. And woven through it all are surprising truths that challenge what we think we know about cold, light, and life itself. Winter is a quiet frontier, filled with strange facts that shimmer just beneath its icy surface. And while you're settling in, before your eyes grow too heavy, I'd love it if you gently tapped subscribe or pressed the little hype button YouTube recently added. It's a small click, but it helps keep these experiments and explorations orbiting out into the algorithm. You can also leave a comment telling me where you're listening from and what time it is in your corner of the night. It's oddly fascinating to see where people are drifting off with us, scattered across the world like stars across the galaxy. Now take a deep breath, let your day drift away, and let's travel together into the quiet corners of the universe. The first snowflake begins as something almost too small to imagine. A dust mote drifting through a cloud so cold that water vapor clings to it in a thin, shimmering film. Nothing about that beginning suggests the intricate sculpture it will become. It is only a speck suspended in turbulent air, carried upward, then dropped, then swept sideways again, as if the sky cannot quite decide what to do with it. But in that motion, in those shifting pockets of temperature and humidity, the snowflake starts to grow. Its first crystal plate forms, a tiny hexagon that seems simple at a glance, but already contains the blueprint for everything that follows. Water molecules prefer to lock together at angles that repeat in six-fold patterns, a quiet rule written into their shape. The snowflake obeys without thought, building outward in symmetry as it drifts through invisible gradients of cold. Each branch of the growing crystal extends like a feeling toward the surrounding vapor. Molecules land, freeze, and shift slightly into place, snapping into the lattice with delicate precision. Yet the environment around the snowflake is anything but steady. One side might enter a colder layer where growth accelerates. Another passes through slightly warmer air and slows. Still another meets a burst of moisture that thickens its edges. These subtle changes cascade through the structure. Once a single branch responds to a new condition, its opposite branch echoes the change because the crystal mirrors itself as it grows. In this way, the snowflake becomes a frozen memory of its own journey through the cloud, a map of conditions written into ice. If the air were perfectly still and perfectly uniform, snowflakes might all look nearly identical, simple hexagons repeating with mechanical precision. But the sky is restless. Turbulence stirs the cloud layers. Rising and sinking currents twist and fold the paths of falling crystals. Something as small as the heat rising from another snowflake can alter the pattern of its neighbor. A shift of a few degrees, barely enough to notice on your skin, can transform a branching shape into a slender column. A rise in humidity can turn a flat plate into a delicate fern. Tiny differences accumulate, and because ice growth is exquisitely sensitive to its surroundings, those differences amplify with every moment of descent. Even flakes that begin side by side will soon diverge. One may drift closer to the heart of the cloud where moisture is plentiful, while the other falls into a drier pocket and grows more slowly. Their branches fork at different times. Their surfaces roughen or smooth in response to passing vapor. They bend toward or away from invisible currents. The symmetry remains, but it is always the symmetry of a story unfolding in real time, never repeated in exactly the same way. Scientists studying these crystals compare their growth to a form of natural computation. Each new layer forms based on local conditions, and those conditions change so rapidly that the final pattern becomes a frozen record of countless tiny choices. When you hold a snowflake on your glove, or let one melt on your sleeve, you are witnessing the end of a long, quiet journey. Yet the structure you see lasted only moments. Snowflakes form quickly, growing from molecular seeds into elaborate shapes in the seconds before they fall from the cloud. Some drift long distances, passing through shifting air that reshapes their branches again and again. Others drop so fast through cold, dry layers that they remain small, crisp, and sharp. Some collide with neighbors mid-air, fusing into clusters or fracturing into fragments that become the starting points for entirely new crystals. Nothing about their existence is static. They are sculptures carved in motion, shaped by both order and chaos. The geometry hidden within each flake is more than a visual curiosity. It reveals how matter behaves when pushed to extremes. Water molecules, when they slow enough to lock into ice, seek arrangements that minimize energy. And the repeating six-fold symmetry of the snowflake reflects that preference. Yet the way they fill space along the edges is influenced by chance. Random fluctuations alter the speed of growth at the tips. A brief surge of moisture thickens a branch. A mild warming rounds an edge. These tiny irregularities become amplified in branching patterns that resemble ferns, feathers, or miniature trees. Mathematicians recognize these as examples of fractal growth, patterns where small changes ripple outward into complex forms. It is tempting to imagine that no two snowflakes are alike, simply because the number of possible patterns is enormous. But the truth reaches deeper. Snowflakes grow in open systems filled with unpredictable turbulence. Their shapes depend not only on temperature and humidity, but on how quickly they move, how many collisions they experience, and how the cloud itself shifts around them. Even if two crystals start the same, their paths soon diverge in ways too subtle to track. The sky is a vast and restless laboratory, and each snowflake is an experiment that cannot be repeated. When conditions grow colder, snowflakes often begin as slender needles or hollow columns. In slightly warmer layers, plates and stellar shapes emerge. There is a narrow band where the atmosphere produces the ornate branching forms most people imagine when they picture a snowflake. But even within that band, the possibilities multiply. Some flakes develop long, elegant branches with tiny side branches repeating in smaller echoes. Others flatten into airy discs with ridged edges. Some carry faint rings or stepped patterns where growth paused, then resumed. No part of the sky offers the exact same canvas twice, and so each crystal becomes a singular portrait of winter. And yet within that uniqueness lies something profoundly consistent. Every snowflake shares the same root geometry, born from the same simple tendency of water molecules to connect in repeating hexagonal arrangements. Order lies beneath the chaos. The intricate differences arise only in the final stages, as the crystal responds to shifting conditions. This interplay creates shapes that seem purposeful, yet never repeat. It is nature balancing precision with unpredictability, symmetry with improvisation. If you step outside during a gentle snowfall and let the flakes settle on your sleeve, you may notice that many look similar at a glance. But look closer, and the differences become clear. One branch grows thicker than its counterpart. A pattern of ridges narrows sooner on one edge. A single side branch reaches a little farther before curling inward. These tiny deviations are the signatures of an individual journey. They tell of a moment when the flake brushed a slightly warmer current or entered a pocket of air richer in vapor. They are artifacts of motion etched in ice. In every winter storm, the sky lifts and drops countless crystals, each one recording its passage without sound. The geometry hidden in those flakes is a gentle reminder that even the quietest parts of nature are shaped by complexity beyond our usual sight. Snow seems simple when it blankets the world, softening edges and muting sound. But within each flake is a history of movement, temperature, and chance, a fleeting sculpture formed from the breath of the clouds themselves. Snowflakes fall, melt, and vanish, but the secrets carried in their shapes whisper that nothing in winter is truly still, and nothing is ever exactly repeated. When winter settles over a landscape, sound begins to behave in ways that feel almost enchanted. The same footsteps that seemed small in autumn suddenly ring out with crisp clarity. A distant door closing seems closer than it is. A dog barking miles away drifts through the cold air as if carried on an invisible thread. None of this is coincidence. The cold reshapes sound at a fundamental level. guiding it through the world differently, bending it along new paths, and revealing tones that remain hidden in warmer months. Even the silence feels fuller, as if the air itself is holding its breath. Sound is nothing more than vibration traveling through a medium, and that medium is heavily influenced by temperature. In warmer air, molecules move quickly, bumping into one another with lively energy. Vibrations scatter and dissipate more easily, softening the edges of every sound. But in winter, the air molecules slow and settle, packed more tightly together. Their stillness becomes a kind of clarity. Vibrations move through them with sharper definition, traveling farther before fading. A single voice or laugh can seem to stretch into the distance, lingering long after the moment has passed. Cold air is a conductor that favors precision over warmth. The structure of the atmosphere also changes with the seasons, creating layers of temperature that can bend sound in surprising ways. On a winter night, the ground cools rapidly after sunset, chilling the air closest to the surface, while the layers above remain slightly warmer. This temperature gradient forms a kind of acoustic mirror. When sound rises from the ground, it meets this warmer layer and bends downward again instead of dispersing upward into the sky. The result is a subtle but powerful amplification. Sounds that would normally drift away return to earth, wrapping themselves around trees, houses, and hillsides. In the quiet of winter, the world seems to echo itself. You may notice this most clearly just after fresh snowfall. Snow absorbs sound at first, its surface filled with tiny pockets of air that trap and soften vibrations. The world becomes hushed, as if wrapped in a blanket. Roads seem farther away. Conversations feel intimate. Even the wind moves softly across the snowpack. But as snow settles and compacts, those air pockets collapse and the surface hardens into something more reflective. Suddenly, footsteps crunching across frozen paths are loud enough to startle. A twig snapping in the woods has a brightness to it, sharp and almost metallic. The transformation from muffled silence to crystalline resonance can happen in a single cold day. Sound in winter also travels differently, depending on humidity, which the cold steals from the air. Dry air carries high-frequency sounds with ease, letting them ring cleanly and travel great distances. You hear this when the wind shifts across icy fields and carries the distant chatter of something you cannot see. The crispness is unmistakable. By contrast, low-frequency sounds often sink and hover, thickening the atmosphere with a faint hum. Sometimes you can feel these sounds more than you hear them. Vibrations moving through the snowpack beneath your feet, spreading outward in wide, slow ripples. The cold makes sound both sharper and deeper, a duality created by the stillness of the frozen air. In forests, winter reshapes acoustics even further. Without leaves to catch or muffle vibrations, branches act like bare instruments, striking notes of their own. When the temperature falls low enough, trees contract, and the tension in their trunks increases until wedges of bark shift or snap with sudden force. These cracks echo strangely across frozen woods, traveling farther than you might expect, sounding almost like distant knocks or the muted ringing of a drum. Some cultures have old names for these winter noises, believing they were the voices of spirits or warnings from the forest itself. Science tells us it is just wood adjusting to the cold, but the eerie resonance remains. Even the ground participates in winter's acoustic transformation. A thick layer of snow can insulate sound, but it can also transmit deep vibrations across great distances when packed tightly. In the far north, people have long noticed that they can hear sled runners or footsteps from afar when the snow is hard and dry. The vibrations skim across the surface as if moving along a frozen drum. Ice behaves similarly. When lakes freeze, their surfaces contract, expand, and flex in slow motion, creating long, echoing booms that ripple across the ice. These sounds can travel miles, rolling through the darkness with an almost wail-like resonance. To hear them is to witness winter speaking in a voice rarely heard. Even wind changes character in winter. It moves through landscapes with less interference, No leaves to whistle against, fewer insects or birds filling the air with competing noise. Over frozen plains, wind can produce a thin, high hum as it passes over sculpted drifts or the edges of brittle ice formations. In canyons or between buildings, winter wind becomes a low, resonant moan, deepened by the dense, cold air. These tones shift constantly, blending with the subtle echoes of the landscape, creating a soundscape that feels both empty and strangely alive. Human-made sounds, too, take on new qualities. The ring of a bell, the scrape of a shovel, even the hum of a distant engine seems sharper in cold weather. Metal contracts, making surfaces more rigid and resonant. Engines work harder, their vibrations carrying through the still air in steady pulses. Even your own breath becomes part of the winter chorus, emerging as a whisper of steam that fades into the silent sky. All of this combines to create a kind of acoustic clarity unique to winter. It is not simply that the world is quieter. It is that sound behaves differently, shaped by the physics of cold and the shifting structure of the atmosphere. The echoes you hear on a frozen morning are not illusions. They are reflections, bends, and returns formed by layers of air acting like mirrors and lenses. Winter is a sculptor, not only of ice and snow, but of sound itself. And in those moments when the cold settles so deeply that the world seems paused, you can sometimes sense a faint ringing in the distance, a barely there vibration carried across miles of frozen land. It is the signature of winter's silence, a silence not empty, but filled with the traces of sound, traveling farther, sharper, and stranger than at any other time of year. Water behaves in winter with a kind of quiet defiance, refusing to follow the rules that most other substances obey. When you watch a lake begin to freeze, or see frost forming along the edges of a window, you are witnessing something far more unusual than it appears. Water does not simply turn solid when it gets cold. It rearranges itself in a way that rewrites the structure of the world around it. It expands instead of shrinking, floats instead of sinking, and reshapes its surroundings with a subtle force that has shaped landscapes and life for millions of years. At first glance, this seems simple. But beneath the still surface of ice lies a collection of mysteries that ripple through every frozen winter. Most materials contract when they cool. Atoms slow down, draw closer, and settle into tighter arrangements. But water contains a hidden quirk. Its molecules form tiny V-shapes, each with a slightly negative end and a slightly positive end. These opposite charges pull on their neighbors, creating fleeting bonds that twist, break, and reattach with constant motion. At warm temperatures, this dance is fast and chaotic. Molecules slide past one another in a restless crowd, slipping into every available space. But as the temperature drops, their movement slows, and the bonds begin to last longer. Slowly, a pattern emerges. The molecules arrange themselves into a lattice that takes up more space than the liquid they came from, pushing outward as they freeze. This expansion is subtle in a glass of water, but unimaginably powerful when writ large across the natural world. In a lake, the forming ice stretches outward across the surface until it locks into a solid sheet. In soil, water trapped between grains of earth pushes them apart as it freezes, swelling the ground and lifting stones with a strength that can split roads and crack foundations. Even the soft, hollow sound you hear when stepping across a frozen puddle is the result of this expansion, a delicate tension straining beneath your feet. Water's refusal to shrink as it cools is not a trivial rebellion. It shapes continents, erodes mountains, and carves out valleys when thawing and freezing repeat over ages. But the strangest part of water's behavior arrives when you place solid ice back into liquid water. Instead of sinking like most solids do in their own melts, ice floats serenely at the surface. This buoyancy is not just a curiosity. It is the reason lakes do not freeze solid from the bottom up, protecting the life within from winter's coldest touch. When water cools toward freezing, something remarkable happens. It reaches a temperature where its density peaks. Around this point, as it gets just a little colder, it begins to expand again instead of continuing to contract. Cold water near the freezing point becomes lighter, rising toward the top, while the deeper layers remain unfrozen and dense. This inversion forms a protective boundary. Ice forms above, sealing in the warmer water below like a natural shield. Underneath that frozen roof, fish move slowly through the dim water, sheltered from the worst of the cold. Tiny organisms drift in currents that continue even as the surface hardens above them. Plant life survives, clinging to the faint glimmers of sunlight that penetrate the ice. Lakes and ponds are not dead in winter. They are quiet worlds preserved by water's peculiarity, worlds that would collapse into silence if ice behaved like the solids we expect. If ice sank, each layer would settle at the bottom, and a lake would freeze upward until life had no refuge. A single winter could sterilize an entire ecosystem. Instead, the frozen surface becomes a window into a suspended world. Even the act of freezing is not as simple as water turning cold and stopping. It resists at first, supercooling quietly, slipping below its freezing point without forming crystals. A lake can hover just above the cusp of solidifying for days, holding its breath while waiting for the perfect conditions. The first crystals appear suddenly, usually at the surface where the cold air draws heat upward. They spread in branching patterns, linking across the water like delicate stitching. These early threads of ice are so thin they flex in the wind, bending before thickening into the rigid shell that winter demands. Each stage builds upon the last. Growth happens faster laterally than downward, creating the familiar sheet that forms with a smooth, glassy top and a maze of trapped bubbles and fractures within. As the ice thickens, it develops layers formed from successive nights of freezing and days of subtle melting. These layers trap air, snow, and fragments of the lake's own breath. When you look at a block of lake ice, the cloudy stripes running through it are evidence of all the moments the water tried to freeze, resisted, thawed slightly, and then froze again. Each band is a record of winter's shifting mood. Scientists sometimes describe ice as a crystalline archive, a structure that remembers every fluctuation of temperature and wind. Under a microscope, its geometry becomes a world of hexagons and filaments, so intricate that it seems almost alive. The buoyancy of ice also transforms the surface of rivers, where water never stops moving beneath the crust. As ice forms on a flowing current, it breaks into floating plates that collide, stack, and jam together. In some places, they overlap like shingles, creating a textured mosaic that cracks and groans as the river shifts below it. The sound can be startling. These are the moments when water and ice negotiate their boundaries, each pushing the other in a slow dance that echoes across frozen valleys. Even in stillness, the surface is alive with tension and release. On a smaller scale, the expansion of freezing water creates delicate structures that appear briefly and disappear just as quickly. Frost heaves push soil upward, lifting blades of grass on tiny columns of ice. Needle ice forms overnight when moisture in the ground rises and freezes into thin, upward-growing spikes that collapse as soon as touched. These fragile formations are miniature versions of the same forces that tear apart stones and reshape mountainsides. They remind us that the cold is always at work, even in quiet corners of the world. In truth, water's behavior as it freezes is not strange because it breaks natural laws, but because it follows them so elegantly. Its structure, its charge, its geometry, and the shifting movement of its molecules combine to create a phenomenon that feels both simple and miraculous. Ice floats, and in doing so, it safeguards entire ecosystems. Water expands, and through that expansion, it sculpts the planet. The cold does not simply harden water. It transforms it into a medium that writes winter's story in crystal and pressure, and beneath every frozen lake, beneath every frost-covered stone, beneath every silent sheet of ice clinging to a river's edge, that story continues to unfold, shaping the world one molecule at a time. Winter light behaves like it has secrets. It only reveals when the world grows cold enough to listen. The sun lowers toward the horizon. The air fills with drifting crystals too small to see, and suddenly the sky begins to bend light into shapes that feel almost otherworldly. Halos shimmer around the sun like faint crowns. Columns of light rise from street lamps and stars as if the night has grown tall. And on rare mornings, fragments of the sun appear beside it, glowing with soft colors that follow you across the sky. These displays seem magical, but they are born from the most delicate of ingredients: ice crystals suspended in the air, turning the winter atmosphere into a quiet prism. When temperatures fall low enough, tiny hexagonal crystals float through the air like invisible dust. They form in high cirrus clouds or drift near the ground as fine diamond dust, especially in the coldest regions. They may be no larger than a grain of salt, yet their shapes matter immensely. Some are plates that glide through the air with their flat faces aligned horizontally. Others are slender columns that tumble slowly as they fall. Light entering these crystals bends at precise angles, splitting into arcs, circles, and pillars, depending on how the crystals are arranged and how the sun strikes them. Without these frozen specks, winter light would remain ordinary. With them, the sky becomes a canvas of geometry and glow. Halos are among the most common of these winter illusions, yet they feel anything but common when you see one. A halo forms when light enters one face of an ice crystal and exits another, bending by just the right amount to create a ring around the sun. This ring is usually faint, a pale circle at about 22 degrees from the sun, but sometimes it sharpens into a clear white band. Other times it brightens with colors, red on the inside and blue on the outer edge. The effect is subtle and delicate, like the ghost of a rainbow. But unlike rainbows, halos can appear even in the deepest cold, when no liquid water is present and the world seems stripped of life. They remind you that even in the starkest winter, the sky remains full of hidden activity. More elaborate halos form when the crystals in the air align in specific ways. Horizontal crystals create bright arcs at the top and bottom of the circle, sometimes forming a complete ring. Vertical crystals generate rare shapes like parhelion arcs, or complex patterns that coil around the sun like thin, luminous threads. The atmosphere becomes a vast optical instrument, sorting and bending sunlight into forms that last only a few minutes before drifting away. To witness such a display is to glimpse the sky thinking in geometry. Perhaps the most striking of all winter light phenomena are sundogs. They appear as bright patches on either side of the sun, usually at the same elevation, glowing softly with tint of red near the sunward edge and shifting into pale blues on the outer side. They can be mistaken for small secondary suns, following the real one as it rises or sets. Sundogs form when flat plate crystals hover in the air like tiny mirrors, catching and redirecting sunlight horizontally. Their glow intensifies when the air is filled with diamond dust, turning an ordinary morning into something that feels quietly surreal. Travelers in ancient times believed these false suns were omens, signs from the sky that the world was shifting. In truth, they are simply the work of drifting crystals, yet their presence still feels meaningful, as if winter has opened a brief window into something larger. Light pillars are another winter marvel, and perhaps the most ethereal. They appear at night as vertical beams stretching upward from street lamps, headlights, or even the moon. Unlike the solid shafts they resemble, light pillars are not physical structures. They are reflections, created when countless flat crystals fall slowly through the air, each one acting like a tiny floating tile of glass. As the light reflects off these falling mirrors, it extends upward or downward in a shimmering column. The effect can be so precise that the pillars appear to connect earth with sky, vibrant and unmoving despite the constant motion of the crystals creating them. In very cold regions, these beams may line the horizon, each one rising from a distant light source until the landscape looks threaded with quiet, luminous towers. The moon can produce many of the same effects. Lunar halos glow with a pale silver that seems almost soft compared to the sun's sharp brilliance. Lunar pillars stretch faintly into the night, shimmering with a gentler radiance. Moondogs appear like dim echoes of sundogs, subtle enough to miss unless you know to look for the colored edges near the moon. These nighttime displays feel intimate, quieter than their daylight counterparts, as if the moon is whispering rather than declaring. They happen more often than people realize because the light is more delicate, blending into the night unless the air is especially clear. Sometimes the sky grows even more complex. On very cold days, multiple halos can appear at once, forming full circles or overlapping arcs that twist around the sun. Parhelic circles may stretch across the sky like a horizontal halo, running parallel to the horizon and linking the sundogs in a continuous band. Rare upper tangent arcs can form graceful curves above the sun, shifting shape as the sun rises, tightening from a V shape into a smooth arch. These transformations unfold slowly, almost imperceptibly, as if the sky is sketching and revising its own artwork in real time. All of these phenomena depend on conditions that are fleeting. A small shift in humidity, a slight warming of the air, or a change in wind direction can disrupt the alignment of crystals and erase the display. The atmosphere is a careful balance, and winter holds it in place only for a moment. But when everything aligns, the world is transformed. Ordinary sunlight becomes luminous architecture. Streetlights grow taller than the buildings beside them. The daytime sky holds 3 suns. The night becomes threaded with silent beams. What makes these winter lights even more astonishing is their reminder that the world is full of hidden structures. The crystals themselves are so tiny they vanish on your glove in an instant, yet they shape the sky on a scale far larger than themselves. They drift, settle, and spin, creating optical symphonies that require no sound. Winter does not only bring cold, it brings clarity. It sharpens edges, aligns crystals, and reveals the subtle dance of light that is always there, waiting for the air to grow calm and cold enough to let it through. Winter presses itself against the living world with a quiet but relentless force, reshaping the creatures that inhabit its reach. Many animals do not merely endure the cold, they transform for it. Their bodies alter in ways that seem almost impossible, shifting chemistry, slowing time, rearranging cells, and rewriting the rules that govern life itself. When the temperature drops far enough, the boundary between survival and stillness blurs, yet nature continues in forms adapted to cold that would stop a human heart. These transformations are subtle, intricate, and astonishing, hidden beneath fur, feathers, and frost. As winter begins its slow descent, one of the most remarkable metamorphoses occurs in small creatures that seem too delicate to survive the season. Wood frogs, for instance, meet the cold with a strategy so bold it borders on the unbelievable. When the temperature falls, they allow their bodies to freeze. Not just slowing, not just sleeping, they freeze solid. Their hearts stop beating, their blood ceases to flow, ice forms between their organs and beneath their skin. In almost any other creature, this would be the end, a final stillness. But for the frog, it is only an intermission. Their bodies flood with glucose that acts as a natural antifreeze, protecting their cells from damage. They remain motionless beneath leaves and snow, holding winter within them until spring softens the air. Then the ice melts, the heart resumes its rhythm, and life begins again, as if awakening from an impossibly deep dream. Other animals take a different approach, avoiding the harshest cold by slowing their lives to a near standstill. Bears, with their thick fur and heavy bodies, enter a state that is not quite sleep and not quite full hibernation, but something between. Their heart rate drops. Their body temperature lowers just enough to save energy but not enough to freeze. They recycle waste internally, preventing toxic buildup. Even wounds begin to heal more slowly but more completely than in the warm months. A bear can endure months without eating or drinking, sustained by the quiet burn of stored fat. When spring returns, they emerge with muscles intact and senses sharpened, as though the long winter were merely a pause in their story. Underground, beneath layers of frozen soil, smaller mammals slip into deeper forms of stasis. Ground squirrels can lower their heartbeats to just a few each minute. Their body temperature drops close to freezing, far lower than that of bears, pushing them into a fragile equilibrium where life hovers on the edge. Every dozen days or so they briefly warm themselves, a mysterious cycle scientists still struggle to fully understand. These pulses may help maintain brain function or keep the immune system ready. Little reminders that even in extreme stillness, life must rehearse its return. Birds, though often symbols of warmth and motion, have their own winter strategies. Some thicken their feathers until their bodies seem wrapped in downy insulation, more effective than any human coat. Others enter nightly torpor, lowering their energy needs until the morning sun restores their strength. The tiny chickadee, so light it can fit in a child's hand, raises its body temperature during the day and then lets it fall at night by amounts that would be dangerous for larger animals. This controlled descent conserves precious energy, allowing such small creatures to survive days when food is scarce and the cold is sharp enough to freeze breath in the air. Some birds change themselves even more dramatically. Ptarmigans turn white, not just on the surface but deep within each feather where tiny air pockets form layers of insulation. Their feet widen and grow feathery tufts that function almost like natural snowshoes, allowing them to perch on powder without sinking. They burrow into snowbanks for shelter, letting winter itself become the blanket that keeps them warm. The cold becomes something they can use rather than something they must escape. In the ocean, where winter reaches with even darker stillness, creatures adapt in stranger ways still. Fish in polar waters produce antifreeze proteins that bind to ice crystals, preventing them from growing and damaging cells. These proteins work silently within their blood, keeping it liquid at temperatures that would freeze most other animals solid. Some species carry these adaptations year-round. The sea around them is so cold that survival requires a perpetual defense against ice that wants to seed and spread within their bodies. For them, winter is not a season, but a permanent reality that shapes every aspect of their existence. Even the fur of mammals shifts when the cold tightens its grip. Arctic foxes undergo one of the most dramatic coat changes in the animal kingdom. Their summer fur is gray-brown, blending with tundra landscapes, but as winter approaches, it transforms into thick white layers that trap heat while erasing their outline against snow. Their paws develop fur on the underside, gripping icy surfaces and reducing heat loss. Their tails become fuller, curling around their faces as they sleep to conserve warmth. In the fiercest winters, when temperatures fall lower than what most animals could endure, the fox remains active, navigating a world sculpted by wind and silence. Reindeer adjust not just their coats but even their eyes. In summer their eyes are golden. In winter they shift to a deep blue color. This change alters how light passes through the tissues, improving vision in the dim polar twilight. Their hooves harden when the ground freezes, allowing them to break through ice to find food or gain footing on slippery slopes. Their entire anatomy bends to the winter landscape, evolving for a world where darkness and ice last for months. Insects, too, make extraordinary changes. Some produce glycerol, a natural antifreeze that prevents ice crystals from forming inside their cells. Others dehydrate themselves almost completely, removing the water that could freeze and damage their bodies. A few tuck themselves into bark crevices or beneath snow, where the temperature remains stable, insulated from the worst of winter's reach. These strategies are small in scale, quiet, and almost invisible, but they are acts of survival that echo through the forest. What unites all these transformations is a simple truth. Winter does not just test life, it reshapes it. It asks animals to bend, pause, or reinvent themselves, and in doing so reveals the adaptability woven into the natural world. Beneath snowdrifts, inside dens, and across frozen oceans, creatures continue in forms that seem almost miraculous. They remind us that survival is often an art of change, learned and refined over countless generations. And when the first warmth of spring arrives, each one resumes the rhythm. Winter only temporarily subdued, carrying the memory of that deep cold within them as they step back into the light. After a fresh snowfall, the world feels as if it has been gently placed under glass. Every sound softens. Footsteps sink into the ground and vanish. Roads that once hummed with distant motion fall quiet. Even the wind seems to move differently, gliding rather than brushing, as though the air itself has grown cautious. This silence is not imagined. It is real, measurable, and shaped by the delicate structure of snow and the way winter transforms the atmosphere. Yet even when we explain it, the effect feels almost mystical, as if the world is holding its breath. When snow first falls, it arrives as billions of tiny crystals, each with its own lacy geometry. Their shapes trap air in ways that form a maze of open space between them. To sound, this is a landscape of endless corridors and soft angles. As a sound wave travels, it enters this porous layer and scatters. Vibrations that once bounced cleanly off hard ground or pavement now disperse inward and fade. The snow absorbs them, pulling their energy into the spaces between crystals. What might have echoed becomes a whisper. What might have rung out becomes muted. The world grows quieter, not because sounds stop happening, but because they can no longer travel far enough to reach us. This absorption is strongest right after snowfall, when the crystals are still sharp and delicate. Over time, snow compacts under its own weight, pressing out much of the trapped air. The surface becomes firmer, smoother, and more reflective. Sounds begin to bounce again, sometimes even louder than before. But in those early hours, the blanket of new snow behaves like a perfect acoustic sponge. It softens the edges of every sound, leaving the landscape wrapped in an unusual calm. You can walk down a familiar street and feel as though the city has stepped back, distant and softened by a veil of winter. The silence deepens because snow also changes the way we perceive space. Without clear echoes returning to our ears, our sense of distance shifts. Things seem farther away. Movement feels slowed. Even our own footsteps sound hesitant. Snow does not erase sound entirely, but it changes the relationship between the listener and the world. A single voice may seem to fall at your feet rather than carry outward. A dog barking in the distance blends into the hushed air instead of slicing through it. This dampened atmosphere creates an intimacy with the present moment, the feeling that everything has drawn slightly closer even as the world itself has grown quieter. There is another layer to winter silence, one born not from the snow, but from the air above it. Cold air tends to be still, especially after a snowfall when wind often calms. When temperatures drop, the air near the ground becomes denser than the warmer layers above. This temperature inversion suppresses vertical mixing, meaning less movement, less rustle, less atmospheric noise. Even the wind behaves differently. It glides low and soft rather than tumbling and swirling. The usual background hum of air moving through branches or across rooftops weakens until it nearly disappears. The sky, too, becomes quieter. Animals respond to this stillness. Birds stay tucked within their shelters, conserving energy. Insects lie dormant beneath the snow. Even the small scurrying noises of nocturnal creatures diminish after a storm. The world is caught between motion and rest. Life continues, but more slowly, with caution shaped by the cold. These changes add to the impression that winter has muted everything. In truth, it is a rare moment of minimal activity layered atop the acoustic dampening of fresh snow. Human sounds shift as well. Cars move more slowly on slick roads, their tires muffled by slush rather than buzzing on pavement. Engines seem softer when insulated by snow-lined streets. Footfalls no longer click or crunch sharply. They compress softly into powder, producing low, brief sounds, swallowed almost immediately by the ground. Even conversation feels different outdoors. Voices do not bounce back but dissolve into the quiet air, making people instinctively speak more gently, more intimately. The environment shapes the mood, guiding us towards softness without our realizing why. In forests, the effect is even more dramatic. Snow clings to branches and needles, wrapping trees in layers that absorb sound from above as well as below. Paths that once echoed with every step become silent corridors. If a breeze arrives, the faint hiss of snow falling from branches replaces the usual rustling of leaves. Lakes crusted with frost stop lapping at their shores. The landscape falls into a hush so complete that even distant sounds become noticeable. A twig snapping half a mile away may carry through the quiet as if magnified by the stillness, and yet the silence is not emptiness. It is a gathering of small sounds that would normally be overwhelmed. The faint crackle of crystals settling, the soft sigh of your own breath mixing with cold air, the subtle shifting of snow under its own weight. These quiet details rise into awareness only when louder noises have been absorbed or suppressed. Winter invites us to listen differently, not just to what is present, but to what has gone missing. Fresh snow also changes the psychological texture of sound. The brightness of the landscape, the slowed motion of life, and the crisp air all create a sense of pause. We become more attuned to subtlety, more conscious of stillness. Our minds interpret this reduced sensory input as peace, even though the underlying cause is purely physical. The silence after snowfall reminds us of the scale of natural forces, the way light and temperature can shift the entire soundscape of the world, reshaping our perception without warning. There is a moment in winter, often just after the last flakes have fallen, when you step outside and feel as though the world has been reset. The air holds its breath, the ground listens, sound travels differently, softly, carefully. It is not the silence of abandonment or emptiness. It is the silence of a world resting beneath a blanket of crystal, waiting for the next breath of wind or the next footstep to mark the beginning of movement again. When a lake freezes, it appears to fall into stillness. The surface becomes a sheet of pale glass, wind-carved and silent, stretching toward the horizon with no hint of motion beneath it. To anyone standing on the shore, it seems as though life has been sealed away, paused until the thaw returns. But beneath that frozen shell, the lake remains alive in ways the surface cannot reveal. Water moves slowly in layered currents. Plants continue to breathe in the dim filtered light. Fish drift through pockets of warmer water, adjusting their rhythms to the long, cold season. The ice above them becomes a ceiling they cannot break, but it is also a shield that protects a world still in motion. When winter settles over a lake, the first ice forms delicately. Crystals gather at the surface, linking in thin patterns shaped by wind, temperature, and the last traces of autumn warmth lingering in the water. As the air grows colder, the crystals thicken and merge, forming a continuous sheet that strengthens with each passing night. Snow may fall atop it, dimming the light that reaches below. To the casual eye, the lake has entered a deep and undisturbed sleep. Yet beneath this quiet armor, the water maintains a temperature just above freezing, a fragile but crucial balance that allows life to endure. Fish are among the most active inhabitants beneath the ice, though their movements slow and their bodies conserve energy with remarkable precision. Their metabolism drops gently, allowing them to survive on minimal food for months at a time. Species like perch and trout retreat to deeper waters where temperatures remain stable. They glide in slow arcs, avoiding sudden movements that waste precious energy. Many gather in subtle clusters, sharing the faint warmth that lingers where the water is densest. They communicate through vibrations, through currents, through the delicate shifts that ripple through the dark. Their world is dim and cold, but it is far from empty. Plants beneath the ice enter their own winter state. Some die back, returning nutrients to the water, while others continue to photosynthesize using the faint threads of light that filter through snow and ice. In the shallows, strands of algae cling to the undersurface of the ice, thriving in the very place where the frozen world above meets the liquid realm below. These microscopic plants provide oxygen that sustains the entire ecosystem during the long season when no atmospheric exchange can occur. Even when the surface appears barren, a delicate chain of life grows in the shadows. Invertebrates live here too, small creatures that swim, crawl, or drift in the slow winter currents. Water fleas and copepods move with gentle pulses of their limbs, feeding on the algae that bloom beneath the ice. Their populations may shrink in the cold, but they never disappear entirely. They serve as food for fish, continuing the cycle even in the coldest months. Some species survive by lowering their internal freezing point, producing substances that prevent ice from forming inside their cells. Their bodies become tiny vessels of resilience, carrying the lake's future into spring. Bacteria remain active as well, breaking down organic material that settles to the lake bed during autumn. Their work releases nutrients that nourish plants when sunlight returns. In this way, the bottom of a frozen lake becomes a quiet workshop, processing the remnants of warmer seasons. Even in the darkest depths, life continues in slow and persistent patterns. One of the most fascinating features of winter lakes is the quiet circulation of water beneath the ice. When the surface freezes, the water below stratifies. The coldest layer sits just under the ice, while slightly warmer water settles deeper. This layering creates a stable environment where life can survive even when the air above reaches severe cold. The ice acts as insulation, preventing the lake from freezing solid. Without this protective layer, many freshwater systems would turn to solid ice each winter, erasing the life within them. Instead, the ice becomes a barrier that holds warmth beneath, preserving a sanctuary unseen from above. Stringy formations sometimes appear on the underside of lake ice, clusters of algae or bacterial filaments that form in response to the low light. They sway with the movement of the water, fragile threads that capture nutrients drifting by. To a diver, this underside of the ice looks like a floating forest of pale green strands, a landscape completely hidden from those walking on the surface. It is a reminder of how much thrives in places we rarely witness. Sound also travels differently under the ice. Whales and dolphins in ocean environments use ice as an acoustic lens, but even in freshwater lakes, vibrations move in strange and haunting ways. Fish hear shifts in pressure. Invertebrates sense faint tremors that pass through the water. When the ice above cracks from thermal expansion, the sound booms through the lake like a deep metallic voice, echoing through the layered world below. These cracks are not signs of danger for the animals. They are part of the winter soundscape, a signal that the ice is adjusting to temperature changes. An icy lake may look silent from the outside, but beneath the surface, it is filled with subtle motion. Particles drift. Plants pulse with slow metabolic rhythms. Fish flick their fins, rearranging the currents. The lake becomes a world of soft movements and muted colors, illuminated only by the slightly blue light that filters through the frozen ceiling. If you could drift there for a moment, suspended between the lake bed and the ice, you would feel the weight of winter pressing down, but also the persistence of life rising up to meet it. And when spring returns, the first cracks in the ice allow sunlight to pierce deeper. The water warms by just enough to awaken the dormant plants. Algae bloom. Invertebrates reproduce rapidly. Fish stir from their winter lull and ascend toward the changing light. The entire ecosystem stretches, breathes, and begins again. The frozen lake, which seemed motionless for so long, reveals that it never truly slept. It only waited, holding life quietly in its depths until the world above was ready to thaw. Winter storms begin long before the first snowflake falls. They start as faint disturbances in the sky, delicate ripples of pressure drifting through the atmosphere. These shifts are small at first, almost impossible to detect without instruments, yet they carry the seeds of something far larger. A whisper of cold air slides beneath a layer of warmer, moisture-rich currents. The two begin to circle each other, exchanging heat and momentum, pulling energy from the contrast between them. What begins as gentle turbulence can, under the right conditions, grow into something immense. By the time the world below notices, the storm has already been building for days, sculpted by forces that meet and merge high above the ground. At the heart of many winter storms is a boundary where warm and cold air collide. This zone sharpens as temperatures drop, becoming a kind of atmospheric fault line. Warm air, full of moisture drawn from oceans or lingering autumn lakes, rises swiftly. Cold air sinks and spreads. The rising currents cool rapidly, releasing their stored water vapor as ice crystals that gather into clouds. If the contrast in temperature is sharp enough, that boundary begins to twist. A low-pressure center forms, a place where air rushes inward and upward, feeding the storm. The greater the energy difference, the faster the storm intensifies. As these currents strengthen, snowflakes begin forming within the clouds. Each one grows from a microscopic nucleus of dust or salt, collecting moisture molecule by molecule. The crystals branch, bend, and shift as they rise and fall through pockets of varying humidity. Some tumble into colder regions and grow delicate arms. Others drift through slightly warmer layers and gather soft, rounded shapes. Millions of these crystals begin falling, but only when the storm's core achieves enough lift and rotation does the snow become truly dense. What was once a gentle flurry transforms into a curtain of white that blurs the horizon. Blizzards are born when the storm reaches a threshold where snowfall meets strong winds. Even light snow can become dangerous when pushed horizontally by gusts that sweep across open fields or through city streets. These winds form when cold, high-pressure air spreads outward and races toward the storm's low-pressure center. Like rivers seeking the lowest point, these currents accelerate as they flow, creating narrow jets of powerful wind that bend trees, sculpt snowbanks, and erase familiar landmarks. A blizzard is not defined solely by snowfall, but by the combination of snow, wind, and visibility. It is a storm that strips the world down to shapes and shadows, making distance dissolve. Inside this swirling system, the atmosphere becomes layered with subtle but powerful gradients. One pocket of air may be only a few degrees colder than another, yet it can make the difference between wet flakes, dry powder, or pellets of ice. If warm air slides just slightly above freezing, snowflakes may partially melt, refreeze, and fall as sleet. If temperatures hover near a delicate boundary, freezing rain can glaze every surface until tree branches groan under its weight. The storm's exact form depends on these thin, shifting layers stacked like invisible pages in the sky. Even a change of 1 or 2 degrees can transform the character of the storm. The jet stream plays a crucial role as well. High above, it flows in winding bands that steer storms across continents. In winter, the jet stream dips lower, carrying cold polar air further south than in warmer seasons. When it bends sharply, it can trap storms in place or accelerate them with remarkable speed. A stalled storm can bury towns under snow that accumulates hour after hour, compacting under its own weight. A faster-moving storm may sweep across the landscape in a single day, but leave behind drifts taller than cars. The shape of the jet stream determines not only where the storm travels, but how fiercely it grows. Moisture is the storm's fuel, and the most powerful winter systems often gather it from great distances. Air flowing over unfrozen lakes can pick up vast amounts of vapor, creating narrow bands of lake-effect snow that appear suddenly and vanish just as quickly. A single band may hover over one location, pouring snow in a concentrated line, while nearby areas remain clear. When storms draw moisture from oceans, they can grow far larger, forming nor'easters or intense mid-latitude cyclones that lash coastlines with snow, sleet, and roaring winds. The source of the moisture shapes the storm's character, whether soft powder or heavy wet flakes that cling to everything they touch. As a winter storm intensifies, its structure becomes more organized. Bands of snow form in curved arcs, feeding into the center like spokes on a wheel. Within these bands, small upward currents create localized bursts of heavy snowfall. These pockets, called mesoscale features, can drop several inches in a single hour. They are the hidden engines of many blizzards, forming suddenly, disappearing without warning, and reshaping the storm's footprint on the ground. People caught inside these bursts may experience a world reduced to silence and swirling white, a momentary immersion in the storm's deepest core. Temperature changes at the surface contribute to the storm's impact. The ground may radiate heat upward, softening the snow as it falls, or it may be cold enough to freeze the first flakes instantly, creating a slippery layer that becomes the foundation for everything that follows. When winds pick up, snow on the ground is lifted into the air again, blurring the distinction between what is falling and what is already fallen. The landscape becomes a shifting mosaic of dunes and sculpted ridges, shaped entirely by air in motion. And yet, despite the scale of these storms, they are always the result of countless gentle beginnings, a slight dip in pressure, a narrow ribbon of moist air rising toward colder layers, a subtle bend in the jet stream. The atmosphere is full of such quiet instabilities, and when they align just right, the result is a storm that transforms the world for a time. Blizzards are reminders that even the most massive events can be born from delicate ingredients, stitched together by temperature, wind, and the invisible architecture of the sky. When the storm finally passes, the world emerges slowly from its cocoon of snow. The wind calms, the clouds thin. What remains is a landscape reshaped, softened, and bright. Drifts glow beneath pale winter light. Trees stand coated in white. Roads vanish, then reappear as people dig pathways through the transformation. The storm that seemed so powerful becomes a memory, but the atmosphere continues to shift and sway above, preparing quietly for whatever comes next. When winter cold settles deep into the ground and the air above turns even colder, something strange begins to happen beneath the surface. Moisture trapped in soil or resting in tiny pockets between grains starts to rise instead of sinking. As it moves upward, drawn by gradients of temperature and pressure, it freezes in delicate columns that push soil grains aside and lift pebbles as though guided by invisible fingers. These are ice needles, slender crystal pillars that grow not downward from the air but upward from the earth itself. To someone walking past them, they might look like frost forced through the ground, but up close they reveal an intricate scaffold of ice reaching toward the sky from below. Their formation depends on conditions so precise that they vanish with the slightest change, leaving behind only softened soil that collapses when touched. Ice needles form through a simple but striking mechanism. As the surface cools rapidly during the night, the temperature below remains a little warmer, creating a subtle but persistent gradient. Water in the soil migrates upward toward the freezing front, pulled along tiny channels by capillary action. When it reaches the cold boundary, it freezes, adding a thin layer to the growing needle. Each moment of freezing pulls more moisture from below, extending the crystal further into the air. Thousands of these structures can form at once, lifting entire sheets of dirt or moss. They are fragile and temporary, breaking with a whisper at the lightest touch, but in their brief existence they reveal how winter can coax growth from places that seem entirely still. Another formation that captures the imagination is frost flowers, delicate clusters of ribbon-like ice that bloom on stems or driftwood when conditions are calm and very cold. They form when water inside a thin plant stem freezes and expands, creating tiny cracks that allow moisture to seep outward. The moment it meets the frigid air, the water freezes into curling petals that look almost like spun sugar or delicate paper shavings. These flowers grow petal by petal as vapor from the stem continues to escape, forming curls and spirals that radiate outward in breathtaking patterns. They are often found in early winter before deep freezes lock the landscape tight. Their presence feels like a quiet greeting from the cold, a moment when winter dresses the simplest things in ephemeral beauty. Surface hoarfrost is another winter marvel, forming not from liquid water, but from water vapor that transitions directly into ice. On calm nights when the air is clear, surfaces that radiate heat quickly become colder than the surrounding air. Vapor from the atmosphere lands on these cold surfaces and crystallizes instantly into feathery structures. Hoarfrost can grow in all directions at once, creating spikes, plates, and branching formations that shimmer like silver filigree under morning light. Each tiny crystal builds on the last, creating a forest of ice so delicate that a breath of warm air can collapse it. Yet in that fragility lies its charm. Hoarfrost reveals the motion of air currents as it grows, tracing invisible patterns across windows, fences, and branches. There are moments when the frost seems to mimic living forms. On some mornings, you might see frost ferns spread across the glass of a window, branching into shapes that resemble the leaves of ferns or the delicate fronds of underwater plants. These patterns form when water vapor condenses on a surface that has slight imperfections or subtle temperature differences. Each tiny grain or scratch on the glass becomes the seed of a crystal, and as the crystal grows, it directs the path of the next branch. The result is an image that looks almost biological, as if winter itself had painted a garden of frozen leaves overnight. The patterns vary from one window to the next, influenced by drafts, humidity, and the faint warmth from inside the home. No two frost ferns ever form in the same way. When wind and moisture combine in just the right balance, rime ice can form on trees, railings, and mountain cliffs. Unlike hoarfrost, which grows in still air, rime ice forms when supercooled fog droplets strike a surface and freeze instantly. These droplets build into thick layers that grow outward in the direction of the wind, forming spiky, sculptural growths that look like feathers or white claws. Hikers in mountainous regions often see entire forests coated in rime, the branches elongated with frozen plumes that reveal the direction of the storm that created them. Rime ice can grow heavy and dense, bending trees under its weight. Yet even in its harshness, it forms structures that feel otherworldly, as though touched by some wandering winter spirit. One of winter's most puzzling sights is the appearance of penitentes, tall, thin blades of hardened snow that point toward the sun. Though more common in high-altitude regions, their formation is a testament to the strange ways winter shapes the landscape. Penitentes form when sunlight causes snow to sublimate directly into vapor without melting first. As small depressions form, they concentrate light and heat, accelerating sublimation in those pockets while leaving the surrounding ridges intact. Over time, the landscape transforms into a field of snowy spires, some taller than a person, all aligned with the direction of the sun. It is the cold shaping itself into a silent congregation, standing motionless beneath the sky. Even indoors, winter can leave patterns that feel like messages. On windows where moisture is trapped between panes or on glass doors exposed to steady drafts, frost can create elaborate pathways that look like maps, branching networks, or written symbols. These patterns form as water vapor seeks surfaces cold enough for crystallization. Each crystal pathway becomes a guide for the next, expanding outward like veins tracing across the glass. People have long looked for meaning in these forms, imagining animals, landscapes, or even letters hidden within them, but they are simply the product of physics, humidity, and the subtle imperfections of the surface. Perhaps the most enchanting frost phenomenon occurs when ice grows upward in crystalline columns so long they resemble frozen hair. This is called hair ice, and it forms only under very specific conditions involving decaying wood and a certain type of fungus that prevents water from freezing into solid blocks. Instead, the water extrudes through tiny openings in the wood, freezing into threads thinner than a human hair. These threads curve and twist in soft waves, creating something that looks almost alive. Under a soft breeze, hair ice can appear to flow or ripple, though it is locked in stillness. Its presence is rare, making it feel like a secret shared only by the forest and the cold. All these formations arise from the same ingredients: water, air, temperature, and time. Yet each one expresses winter differently. Some grow upward, defying intuition. Others branch into lace or curl into petals. Some form only in silence, while others grow in the teeth of a storm. What they share is their fleeting nature. They appear, astonish, and then vanish with the slightest shift in weather. Winter may seem harsh at first glance, but these subtle creations reveal a softer truth. The cold sculpts delicacy as easily as it shapes ice into strength. It builds worlds that appear overnight and vanish by noon. It turns invisible forces into visible art, and it reminds anyone who pauses to look closely that even the coldest season is filled with quiet acts of creation. Far above the quiet winter world, long before dawn colors the horizon, something begins to stir in the sky. At first it is only a faint glow, a whisper of green brushing the edge of darkness. It hovers there like a memory, barely visible, shifting so gently that you might mistake it for a cloud catching distant moonlight. But as the night deepens, the glow strengthens, gathering into waves that curl and unfurl like slow-moving rivers of color. This is the beginning of the Northern Lights, a phenomenon that feels both ancient and alive, born from forces that reach across unimaginable distances to touch the upper layers of Earth's atmosphere. The aurora begins with the sun, that steady and distant star whose surface is much less calm than it appears. Jets of charged particles stream outward from its surface in all directions. Sometimes, when the sun erupts in bursts of flares or coronal mass ejections, it sends enormous clouds of plasma sweeping through space. These particles travel for days, crossing the void before they finally reach Earth. Most planets are surrounded by invisible magnetic fields, and ours is no exception. When the solar wind encounters this magnetic shield, the field bends and stretches like fabric caught in a gust, guiding particles toward the polar regions where the magnetic lines converge. Once these charged particles reach the upper atmosphere, they collide with gases drifting more than 100 miles above the ground. Oxygen and nitrogen, which usually remain unseen in the cold, thin air, become luminous when struck by energetic particles from space. Each collision excites the atoms, nudging their electrons into higher energy states. As they return to their original states, they release photons. The result is light, glowing in colors that depend on the type of gas and the altitude where the collision occurs. Oxygen produces the familiar green curtains that ripple across the sky, while higher altitude oxygen glows deep red. Nitrogen contributes purples and blues that appear at the edges of brighter arcs. Together, these ingredients create the shifting palette that turns the night into a living tapestry. The shapes of the aurora are sculpted by the magnetic field itself. Charged particles spiral along magnetic lines as they descend into the atmosphere. These spirals create arcs and curtains that trace invisible boundaries above the poles. Sometimes the lights move slowly, drifting like smoke. Other times they flicker rapidly, pulsing as though responding to distant storms on the surface of the sun. The brightest displays often coincide with solar events that send surges of energetic particles toward Earth. During those moments, the aurora can stretch far beyond the polar regions, reaching latitudes where people rarely see such displays. Even cities that lie in darkness for most of the year have seen nights lit by shimmering green and red waves. What makes the aurora so captivating is not just its beauty, but its motion. Unlike most natural lights on Earth, the aurora does not stay still. It curls and sways, pulling itself into ribbons that twist across the stars. It folds downward in long veils that seem almost close enough to touch, then rises again, dissolving into thin traces of color before gathering into new shapes. The movement is driven by changes in the flow of charged particles and the shifting dynamics of Earth's magnetic field. In a sense, the aurora is a real-time portrait of our planet interacting with the sun, a dance of energy that plays out across thousands of miles. In regions near the poles, the aurora is a familiar companion during winter. On clear nights, people look to the sky expecting to see something stirring, even if only a faint glow. Yet even those who witness it often never see the same pattern twice. The aurora responds to fluctuations in solar wind strength and variations in magnetic field alignment. It is a phenomenon shaped by both predictable cycles and sudden bursts of energy. And while scientists understand the broad mechanics behind it, the finer details remain complex, a blend of physics, particle motion, and atmospheric chemistry that still holds unanswered questions. The aurora also extends beyond the visible spectrum. Cameras sensitive to infrared and ultraviolet light can detect structures that the human eye cannot see. These hidden layers reveal that the aurora is far larger than it appears, sometimes stretching across hemispheres or forming ovals that circle the poles. Satellites above Earth have captured immense rings of light surrounding our planet like glowing halos. From space, the aurora looks less like a dance and more like a cosmic shield, a sign of how Earth's magnetic field protects its surface from the relentless stream of charged particles pouring from the sun. The visible colors we see from the ground are only one part of a much larger phenomenon that envelops the planet. When powerful geomagnetic storms occur, the aurora can become bright enough to illuminate snowy landscapes in shades of green and violet. Travelers in remote regions describe entire valleys glowing softly as though lit by some hidden lamp. Snow reflects the auroral light, giving it a depth and vibrancy that seems unreal. In these moments, the sky feels impossibly close, a moving canopy of color that bridges the gap between Earth and space. Sometimes, the aurora creates faint crackling or whispering sounds when the charged particles disturb the air, though these reports are rare and still debated. Whether or not the aurora truly sings, its motion has a rhythm that feels musical. Indigenous cultures in the northern latitudes have long woven stories around these lights. Some believed the aurora was the glow of spirits moving between worlds. Others saw them as messages or omens, or as the reflections of fires burning in distant realms. While science explains the mechanics, the sense of mystery remains. Even with knowledge, it is difficult to stand beneath the shifting sky and feel anything other than awe. The aurora speaks in a language of color and motion, a reminder that our planet is part of a larger, dynamic system shaped by forces far beyond our everyday perception. The relationship between Earth and the Sun is written in these lights. The aurora shows us how energy travels across the solar system, how magnetic fields shape the flow of particles, and how the upper atmosphere becomes a canvas for this invisible interchange. Winter, with its long nights and clear skies, offers the perfect backdrop for this display. As temperatures drop and darkness settles in, the conditions align for the aurora to reveal itself in ways that feel intimate and vast at the same time. To watch the northern lights is to witness a conversation between the Earth and the cosmos. It is a reminder that the cold quiet of winter is not emptiness, but a kind of stillness that allows subtle forces to show themselves. Above the frozen ground, beyond the reach of wind and snow, the sky glows with the touch of particles that began their journey on the sun, and for a moment, anyone who looks upward becomes part of that luminous exchange, standing beneath a sky that is alive with color and shaped by the unseen mechanics of the universe. A glacier begins so quietly that most would never notice its birth. High in a mountain range or deep within a polar plateau, snow falls gently year after year, each winter layering itself over the last. In the warmth of summer, some of that snow melts, but the cold always returns, and more snow settles on top. Over decades and centuries, the lower layers become pressed so tightly that their crystals fuse into solid blue ice. What began as countless snowflakes, each unique in its fleeting design, transforms into a single massive body. And though it may look frozen in place, the glacier is already beginning to move, drawn downward by gravity, pulled forward by the weight of its own immense body. It is slow, yes, but never still. Inside a glacier, the ice does not behave like a brittle block. Under enormous pressure, it flows, bending and stretching with the patience of stone. The crystals reorganize themselves, sliding past one another in microscopic shifts that accumulate over time. The glacier creeps forward inch by inch, its motion too slow for the eye to catch but powerful enough to reshape entire landscapes. Valleys that once wound gently between peaks become carved into sharp U-shaped troughs. Boulders embedded in the ice scrape against bedrock, leaving grooves that endure long after the glacier retreats. In this way, the glacier becomes a sculptor, its chisel made of ice and time. Deep within the ice, trapped bubbles hold whispers of ancient air. Each layer contains the atmosphere of the year in which it formed, sealed away beneath thousands of feet of snow and ice. Scientists drill into glaciers to retrieve these frozen records, reading the past through the chemistry of the air inside each bubble. These trapped gases reveal stories of shifting climates, volcanic eruptions, and distant fires. A glacier is more than a river of ice. It is an archive of the planet's memory, preserving moments from ages long before human history began. The color of glacier ice comes from its density. As snow compresses over centuries, the air is squeezed out, leaving crystals so tightly packed that they absorb all colors except the deepest blue. When sunlight filters into the cracks and crevasses, it glows with a hue that feels almost unreal, as if the glacier were lit from within. In some places, meltwater pools into brilliant turquoise lakes on the surface, shimmering under the pale sun. These lakes drain suddenly and violently when cracks open in the ice, sending rushing water downward in a roar that echoes through the glacier's interior tunnels. Although glaciers move slowly, they can shift dramatically under the right circumstances. When the weight of accumulated snow grows too heavy, or when meltwater lubricates the base, the glacier can surge, advancing far faster than usual. These surges are rare, unpredictable, and immense. Villages at the foot of a glacier have sometimes awakened to find the ice suddenly much closer than it had been only weeks before. It is a reminder that glaciers obey no human timeline. Their pace may be measured in centuries, but their moments of sudden motion reveal that they are not passive features of the landscape. They are forces with their own rhythms. At the base of a glacier, the ice melts slowly from contact with the ground's warmth. Meltwater flows beneath the glacier in networks of hidden streams and tunnels, carving pathways that shift from year to year. These subglacial rivers carry rock, sediment, and ancient fossils, grinding them into fine powder called glacial flour. When the water flows into lakes or fjords, the suspended minerals give the water a pale, milky color. Entire valleys downstream glow with this soft tint in summer, a fleeting sign of the glacier's reach. Crevasses form when the glacier bends or stretches over uneven terrain. They open with the slow tension of ice reacting to gravity's pull, creating deep fractures that can plunge hundreds of feet into the glacier's interior. From above, they resemble jagged wounds in the ice, dark and mysterious. To stand near one is to feel the depth of time stretching downward, the cold rising from within like the breath of the glacier itself. Some crevasses close again as the glacier shifts, sealing away whatever fell inside. Others grow wider, stretching like silent reminders that even the most ancient ice is constantly in motion. In polar regions, massive ice sheets behave like glaciers on an unimaginable scale. They flow to the sea, forming towering ice cliffs that calve off into the ocean. When a section breaks free, it becomes an iceberg, drifting silently across cold waters until it melts. The iceberg above the surface is only a small part of the whole. Most of its mass remains hidden beneath the waves, a cold and ghostly structure moving with currents and tides. Each iceberg carries with it the remnants of a glacier's long journey, a traveling fragment of time's slow movement. Glaciers shape ecosystems as well. As they melt, they release fresh water that feeds rivers and supports entire regions. Some valleys rely on glacial runoff during dry seasons, their landscapes thriving on water that began as snow centuries earlier. Even the rocks left behind by a retreating glacier create fertile ground. The fine powder ground beneath the ice enriches the soil, allowing new forests to take root. Life begins again in the wake of ice, growing from the landscape the glacier carved. But glaciers are vulnerable too. Changes in temperature gradually thin their surfaces and accelerate their retreat. Some glaciers, once immense, have already shrunk dramatically within a single lifetime. When they melt, they release the stored water of ages, contributing to rising seas and reshaping coastlines far from where they once stood. The glacier, once a symbol of endurance, becomes a measure of change, a reminder that even the slowest forces can shift rapidly under new conditions. Even so, a glacier's presence is a powerful reminder of the planet's deep time. To stand at its edge is to feel the weight of ages pressing forward. You can hear the glacier crack and groan, sounds born from internal stresses as ice shifts, fractures, and reforms. You can watch as meltwater trickles down from the surface, carrying with it grains of rock that have been frozen in place for centuries. The glacier is constantly remaking itself, constantly moving, constantly remembering. A glacier moves too slowly for a single lifetime to witness its full journey, yet its impact is written across landscapes, carved into mountains, and etched into valleys. It is a river that flows not with liquid water, but with the pressure of time itself. And in its steady forward motion, it reminds anyone who pauses to observe it that the world is shaped not only by sudden storms or quick events, but by quiet persistence, by patience, and by forces that endure long after winter has passed. Winter arrives in a forest, not as a single event, but as a slow and deliberate transformation. The first breath of cold settles between the branches, clinging to bark and gathering in the low places where shadows linger even in daylight. Leaves that fluttered brightly only weeks before fall into stillness, layering the forest floor with fading color. Yet beneath this quiet surface, the forest is not withdrawing. It is rearranging itself, adjusting its rhythms to the long season ahead, reshaping every layer from the canopy to the hidden soil where roots thread through darkness. Trees respond to winter long before the first frost touches them. As the days shorten, they begin to draw nutrients from their leaves, sending sugars and minerals downward into their trunks and roots. The leaves lose their pigments and fall, not as an ending but as a protective measure. By shedding their broad surfaces, trees avoid losing precious moisture to dry winter winds. What remains is the skeleton of the canopy, a lattice of branches that holds the memory of summer yet prepares for months of cold silence. Even in their bare state, the trees continue subtle internal work, strengthening cell walls and creating compounds that act as natural antifreeze. Beneath the bark, water within the tree shifts its behavior to survive freezing temperatures. Some species concentrate sugars in their cells to lower the freezing point. Others move water out of vulnerable areas to prevent ice from forming where it might cause damage. These adaptations are so precise that a tree can withstand temperatures that would shatter many other structures. While the forest appears dormant, each tree is actively maintaining balance, responding to the cold with a patience shaped by centuries of seasonal repetition. The forest floor undergoes its own metamorphosis. As leaves decompose, they form a thick, insulating layer that protects soil from the harshest cold. Beneath this layer, small animals carve tunnels through the warmth of the leaf litter, creating pathways that remain alive with movement even when the world above seems still. Microorganisms continue breaking down organic matter, though their pace slows. Fungi thread their mycelial networks deeper into the ground, transforming fallen leaves into nutrients that sustain the forest when warmth returns. Even in the depths of winter, the soil is not dead. It is a slow-breathing world, quiet but working, holding heat in delicate pockets where life shelters. Roots respond to winter differently than trunks and branches. Though the upper parts of a tree may sleep, the roots continue to grow, seeking water and expanding into the soil. The insulating layer of snow above traps heat and keeps the ground warmer than the air. This warmth allows roots to push through the soil long after the surface has frozen. A forest in winter may seem to have paused, but underground it is extending itself, preparing for spring by investing in the foundations that will support new growth. The trees draw water from deep sources, and through networks shared with fungi, they exchange nutrients and chemical signals that guide their winter behavior. Animals reshape the forest as well, though many move quietly and leave few signs. Deer carve narrow trails through deep snow, creating corridors that other creatures follow. Small mammals burrow beneath the surface, their tunnels creating hidden highways under the snowpack. Birds gather on branches stripped bare of leaves, their movements stirring the air in brief flurries of sound. Woodpeckers tap against trunks, searching for insects that remain dormant just beneath the bark. Each knock echoes through the cold air, a sign that life continues even in the stillest season. The snow itself becomes a sculptor of the forest. When it falls lightly, it gathers on branches in soft layers that dampen sound and soften light. When heavy, it bends young saplings and lowers the crowns of underbrush, reshaping the forest silhouette. Ice storms encase branches in clear shells that glitter in pale sunlight, turning the forest into a landscape of glass. These coatings increase weight and tension, sometimes snapping limbs or altering the growth patterns of trees. The forest emerges from such events with new shapes and openings that change how light will reach the ground in the seasons to come. Wind plays its part, sweeping through the forest with currents that wedge between trunks and race along ridgelines. Winter winds can reveal the strength or weakness of a tree, causing some to fall and others to stand firm. When a tree falls, it creates space for saplings that have waited patiently in the understory. Its trunk becomes a home for insects, moss, and fungi. Its roots lift soil into new mounds where seeds can settle. In this way, winter's harshness becomes a path to renewal, reshaping the forest by opening opportunities for future growth. Even the smallest organisms contribute to this transformation. Microbes beneath the snow continue to generate heat as they break down organic matter. This warmth creates a layer known as the subnivean zone, a hidden world between soil and snow where temperatures remain surprisingly stable. In this quiet space, voles, shrews, and insects travel freely, feeding on seeds and roots. Their movements aerate the soil, mixing nutrients and creating small disturbances that benefit plant life when the thaw arrives. Winter may slow biological processes, but it does not stop them. It channels them into deeper and quieter pathways. When temperatures fluctuate, subtle shifts occur within the trees themselves. Repeated cycles of freezing and thawing can cause bark to crack in long vertical lines known as frost fissures. These openings allow air and light to reach inner layers of wood, offering new habitats for insects and small animals. They also provide entry points for fungi and lichen, which begin to colonize the exposed surfaces. Though these organisms may seem destructive, they play a crucial role in breaking down old wood and returning nutrients to the soil. Winter opens the door for these slow-acting agents of decay, partnering with them to recycle the forest's oldest trees. As snow accumulates, it reflects light upward into the bare branches, altering the forest's colors and contrasts. Shadows stretch long and blue in the low winter sun, and the texture of bark becomes more pronounced. Without the distraction of leaves, the shapes of branches reveal the history of storms, seasons, and years of growth. Each tree stands like a record of its own past, etched in twists, bends, and scars. Winter strips away the excess, allowing the forest to show its structure with a clarity that summer will hide again. And when the thaw finally comes, the forest responds without hesitation. Roots that grew quietly in darkness send nutrients upward. Buds swell along branches that held themselves still through wind, snow, and ice. Soil enriched by a season of slow decomposition awakens in bursts of green. Winter reshapes the forest not by stopping it, but by guiding it into a different kind of motion, a quieter rhythm that prepares every branch and every root for the return of light. Cold has a way of settling into the body with a patience that mirrors winter itself. It does not rush, it creeps. At first, it brushes the skin lightly, a harmless nip that wakes the senses. Then it lingers a little longer than expected, slipping through layers of fabric and resting against the bones. Most of the time, the body adjusts, tightening blood vessels in the skin to preserve warmth, shivering in small bursts to create heat. These familiar reactions are quiet acts of protection, rehearsed over millennia. Yet when the cold sinks too deeply or stays too long, the body begins a slow, dangerous drift into hypothermia, a condition that transforms the familiar world into something distant and muted. Hypothermia begins when the body loses heat faster than it can produce it. Even in weather that does not seem severe, moisture, wind, and fatigue can combine in ways that lower the body's internal temperature. The first signs feel almost ordinary. Fingers grow stiff. Movement becomes clumsy. Words slip into silence as the muscles around the mouth tighten. These small shifts often go unnoticed, yet they mark the moment when the body's core begins its subtle descent toward cold. Inside, the body fights back with everything it has. Blood vessels close around the arms and legs to conserve heat for the heart and brain. Shivering intensifies, each contraction a spark of warmth against the deepening chill. The brain sends urgent signals to seek shelter, to find warmth, to stop the loss. But as the internal temperature drops further, those signals grow quieter. The mind becomes foggy, thoughts slow. The cold begins to feel less threatening and more like a heavy blanket settling over the senses. A strange calm follows. Muscles loosen. The shivering stops, not because the person is warm, but because the body no longer has the energy to continue. This is one of hypothermia's most deceptive stages. Without shivering, it becomes harder to recognize the danger. The skin may turn pale or take on a bluish hue as the blood retreats deeper within. Coordination falters. Steps become uncertain. Words slur. In severe cases, the person may feel a sudden desire to remove clothing, a paradoxical sensation created by failing nerves and misfired signals in the brain. Yet even as cold overwhelms the body, the mechanisms that once helped humans survive winter remain embedded in our physiology. Humans evolved ways to withstand cold long before insulated homes or modern clothing existed. One adaptation is the ability to constrict blood flow in a controlled rhythm. In some populations, particularly those who historically lived in cold climates, blood vessels in the fingers and toes periodically reopen for brief bursts of circulation, preventing frostbite while still conserving heat. This automatic cycling is nature's attempt to strike balance between survival of the core and survival of the limbs. Another adaptation lies in brown fat, a specialized tissue found in infants and in adults exposed frequently to cold. Brown fat burns energy not to fuel movement, but purely to generate heat. Unlike the slow burn of shivering muscles, brown fat produces warmth without motion, radiating heat through the bloodstream. People who spend regular time in cold environments often develop more active brown fat, allowing them to maintain warmth with less strain on the body. It is a quiet furnace tucked beneath the skin, waiting for temperatures to fall. Under extreme conditions, the human metabolism shifts in remarkable ways. Hormones surge to increase energy production. The liver releases sugars to fuel heat-generating processes. Breathing patterns adjust, drawing in cold air and warming it before it reaches delicate tissues. Even the sensation of cold becomes dulled as nerves slow their responses. These adjustments are instinctive, silent, and ancient, crafted by generations of survival in harsh climates. Cultures around the world have also shaped their own methods for enduring winter. Indigenous peoples of the far north developed clothing made from animal hides and fur that insulate better than many modern materials. Their diets, high in fat and nutrient-rich foods, provide fuel for warmth and endurance. Traditional shelters are built with an understanding of airflow, insulation, and the ways snow itself can trap heat. These adaptations are not just biological, but cultural expressions of living in balance with cold. Still, the science of hypothermia reminds us that the human body has limits. The core temperature must remain within a narrow range for the heart and brain to function properly. When it dips too low, the heart rhythm becomes unstable. The brain struggles to send signals. In deep hypothermia, consciousness fades, and a stillness settles over the body that can be mistaken for sleep. Yet even then, recovery is sometimes possible. Cases exist where individuals have been revived after prolonged exposure to extreme cold, their bodies protected by the same slowdown that endangered them. The cold, paradoxically, can preserve. What protects a person most effectively is not only physiology but awareness. Recognizing early signs of hypothermia can prevent the slow slide into danger. Dry clothing, shelter from wind, movement that warms without exhausting, and layers that trap air against the body all play roles in maintaining warmth. Humans may not have thick fur or hibernation cycles, but they have ingenuity, a trait that becomes vital in winter. The mind itself adapts in subtle ways. People living in cold climates often develop an intuitive sense of temperature changes. They can feel shifts in wind that signal incoming storms, read the sky for signs of moisture, and gauge when the cold is merely uncomfortable and when it is dangerous. These skills, learned over seasons and lifetimes, weave into a kind of sensory map that guides survival as much as any biological mechanism. Winter tests the human body, but it also reveals its resilience. Beneath the skin, Silent adjustments keep the heart beating and the blood warm. In the mind, instincts honed over generations whisper reminders to seek shelter, to nourish, to move. And surrounding all of it is the knowledge that cold has shaped humanity as much as fire has. Winter becomes not just a season, but a teacher, showing how fragile warmth can be and how deeply the body strives to protect it. Hypothermia is the cold at its most dangerous, yet human adaptation is the warmth that persists. The two meet in every winter landscape, creating a delicate balance between survival and surrender. And within that balance lies a story of endurance, written not only in science, but in the quiet determination of the human body to hold on to its heat, its life, and its place in the frozen world. Winter has a way of transforming familiar landscapes into something that feels distant and unearthly. In the coldest regions of the world, deserts of snow and ice stretch beyond the horizon, shaped by wind, silence, and time. These places resemble scenes from another planet more than anything found on Earth. Their surfaces are carved into ridges, waves, and crystalline structures that bend light in strange ways. Their air is so dry that snow behaves more like dust. Their temperatures fall so far below freezing that the atmosphere itself seems thinner. To step into these winter deserts is to feel as though you have crossed into a world where the rules of nature have shifted, revealing new forms of beauty and harshness. The driest desert on Earth is not a sun-scorched expanse of sand, but the Antarctic interior, a place so cold that moisture can hardly survive. Snow rarely falls there. What accumulates has often been drifting for centuries, sculpted into intricate patterns known as sastrugi. Wind erodes the surface into sharp ridges and sweeping curves, some as tall as a person, their edges hardened by relentless abrasion. These formations catch shadows in long, sweeping lines, giving the ground the appearance of frozen waves or the surface of a distant moon. The wind shapes them with precision, carving the desert grain by grain until the ice becomes a living map of atmospheric motion. In these vast expanses, the cold is so intense that metal becomes brittle and rubber stiffens into stone. Ice crystals suspended in the air reflect sunlight into halos and pillars that shimmer even at midday. The horizon often appears distorted, bent by temperature gradients that play tricks on the eyes. Mountains seem to hover, floating above the ground like mirages. This phenomenon, called the Fata Morgana, is common in polar deserts, its shimmering illusions born from layers of warm and cold air refracting light. The landscape feels alive with optical mysteries that hint at the same physics shaping distant planets. In Arctic regions, the sea itself transforms into alien terrain during winter. When the ocean begins to freeze, it does not solidify into a smooth sheet. Instead, fragile ice crystals form first, clustering into slushy rafts that thicken and compress. As the ice grows, it buckles and cracks under shifting winds and tides, forming jagged pressure ridges. These ridges rise like frozen mountain ranges, their peaks tinted blue where the ice has been forced upward from deep within the sea. Walking among them feels like exploring a world where water chose to build mountains instead of flowing freely. In some winters, rare and eerie formations appear along lake shores called ice pancakes. These circular flows bump into one another as waves move beneath them, smoothing their edges until they resemble floating discs. When temperatures drop low enough, they freeze into place, creating fields of icy circles that stretch across the water. They look almost artificial, as if arranged by some deliberate hand rather than carved by wind and wave. Their presence blurs the line between natural formation and surreal sculpture. There are places where winter deserts become even stranger. In the high mountains, avalanches can grind snow into fine powders that drift like sand, forming dunes that shift with the wind. These snow dunes behave in ways similar to the dunes of Mars, shaped by currents of air that dance across their surfaces. Scientists study them to understand how wind sculpted the ancient Martian landscape, using Earth's winter deserts as analogs for a world long frozen. The similarities between the two environments reveal how universal the forces of erosion and movement are, whether on a frozen planet or a cold mountain plateau. Some icy landscapes create sounds that seem almost supernatural. In very cold conditions, lakes covered with thick ice emit deep, resonant booms when the surface cracks from temperature changes. These sounds can echo across miles, reverberating like the voice of the landscape itself. In other places, the ice vibrates underfoot, humming softly as if responding to the presence of those who walk across it. The frozen world gains a voice shaped by physics, speaking in tones that feel both eerie and mesmerizing. Even snow can behave in alien ways. In extreme cold, fallen snow does not pack or melt easily. It remains loose and crystalline, crunching under each step with a sound described by travelers as dry and hollow. In Antarctica, the air is so arid that snow sublimates directly into vapor, bypassing the liquid stage entirely. Snow becomes a substance that shifts quietly between states, a reminder that the cold can rewrite the rules of matter. One of the most otherworldly winter phenomena is brinnacle formation beneath polar sea ice. As seawater freezes, it forces out concentrated brine that sinks in cold streams, forming icy stalactites that reach downward like frozen fingers. These brinnacles creep along the seafloor, freezing everything they touch. Their growth can be swift and silent, spreading across marine habitats in a way that looks almost intentional. Watching them form is like observing a natural experiment in alien architecture, where chemistry and temperature collaborate to build structures found nowhere else on Earth. In the farthest reaches of the Arctic night, when the sun has vanished for months, the landscape takes on an entirely different presence. With no light to guide the eye, the world becomes a realm defined by texture and sound. Moonlight reflects off ice crystals suspended in the air, creating halos and glittering arcs. Stars shine with a brightness impossible in warmer climates, their clarity amplified by the cold and the dryness. The sky becomes sharper, more vast, as if it belongs to a different planet where atmosphere and space sit closer together. Humans moving through these winter deserts adopt rituals that resemble exploration more than travel. Every sound becomes meaningful. Every shift in wind feels like a warning or a sign. The crunch of snow, the whisper of drifting particles, the distant fracture of ice all create a sensory environment unlike any other. People describe feeling both grounded and unmoored, as if standing on the edge of Earth's familiar world, while glimpsing another hidden beneath the surface. These icy landscapes remind us that our planet contains places as strange and wondrous as any imagined elsewhere in the universe. Winter reveals them with stark clarity. It strips away the softness of warmer seasons and unveils forms, sounds, and textures shaped entirely by cold. In these places, time feels slower. Light behaves differently. The horizon stretches farther than the mind expects. To walk through a winter desert is to witness the planet in its most elemental state. It is to see Earth not as a home shaped for comfort, but as a world forged by forces older and broader than human presence. And in that frozen silence, where wind sculpts ice into alien forms and the cold preserves ancient secrets, it becomes clear that winter does not merely transform landscapes. It opens a window into realms that echo the surfaces of distant worlds, reminding us that the familiar Earth still holds mysteries vast enough to feel extraterrestrial. Snow, for all its coldness, carries an unexpected warmth within it. When it first begins to fall, it drifts through the air as delicate crystals, each one light enough to be lifted by the faintest breeze. As these crystals accumulate on the ground, they lock together in loose, airy patterns. To the eye, fresh snow appears soft and weightless. But beneath its surface lies a world of trapped air, hidden tunnels, and fragile structures that can cradle life against the very conditions that created it. Snow becomes more than weather. It becomes shelter. The insulating power of snow begins with the spaces between its crystals. Each flake contains tiny arms and branches that interlock loosely when they land, creating countless pockets of still air. These pockets slow the transfer of heat, forming a barrier that keeps warmth from escaping into the sky. Under a thick layer of snow, the temperature of the ground often remains just below freezing, even when the air above plunges far lower. To many creatures, this difference is the line between survival and surrender. Beneath the surface, winter feels less brutal. It becomes a muted season instead of an impossible one. Small mammals rely on this insulated world more than any blanket or burrow. Voles and shrews spend winter in a hidden realm beneath the snowpack called the subnivean layer. To humans, it is invisible unless footprints collapse its roof. But to these animals, it is an entire winter habitat. Here, the air remains mild enough for movement and feeding. The snow above muffles sound, protecting them from predators. Tunnels weave between grasses and roots, forming pathways that remain open as long as the snow stays light and undisturbed. Above them, storms may rage and winds may howl, but beneath the snow there is a hush, a soft stability, a quiet sanctuary carved from cold. Plants, too, depend on snow for survival. Many species evolve to withstand freezing temperatures, but they still rely on snow to shield their roots from the harshest cold. Without snow, the ground freezes deeply, threatening bulbs, seeds, and subterranean stems. But when snow blankets the earth, it forms a thermal shield. The soil beneath remains warmer than the air above, allowing microorganisms to continue their slow work of breaking down organic matter. Roots stretch and breathe in the mellowed cold, preparing for the return of spring. Even dormant forests rely on this protection. Snow becomes an ally to life that seems to have withdrawn. Larger animals use snow's insulating qualities in their own ways. Arctic foxes curl into drifts, letting snow pile around them like a nest. Their fur traps warmth, and the snow adds a layer of stillness that keeps their body heat close. Birds such as willow ptarmigans burrow downward in swirling dives, creating small chambers beneath the snow where they spend the night protected from wind and predators. When the morning sun rises, they burst upward in flurries of white, leaving behind hollow impressions that fade with the next snowfall. In each case, snow serves not as a threat, but as a sheltering partner, transforming cold air into a protective blanket. Humans have long recognized this paradoxical warmth. In northern cultures, snow shelters known as snow houses or snow caves were crafted with care, using compacted blocks that trap air inside their crystalline structure. When built correctly, these shelters stay remarkably warm compared to the open air. A single body can raise the interior temperature dramatically, not by magic, but by the same principles that guide nature. Snow blocks warmth from escaping, allowing even a tiny spark of heat to linger. Inside such a shelter, a person can escape the wind, preserve energy, and survive temperatures that would otherwise be unbearable. Snow also preserves life by slowing decay. When winter settles deep and steady, animals that perish beneath its cover remain intact, far longer than they would in warmer seasons. The cold halts microbial activity, turning snow into a kind of natural time capsule. Beneath it, tracks endure. Leaves retain their shape. Food caches remain unspoiled for animals that return to them later. This preservation extends to human objects as well. Tools, artifacts, and even long-lost remains have been discovered beneath old snowfields, preserved by winter's unintentional kindness. Snow, for all its softness, acts as a guardian of stories, holding them safe until the thaw reveals them. Even its weight can protect the landscape. When deep snow blankets delicate alpine plants, it shields them from drying winds that might otherwise strip their moisture. Without snow, these plants would be exposed to harsh conditions that freeze and desiccate them. Snow insulates them like a white cocoon, ensuring their survival until the sun returns. Some species depend so heavily on this cover that years with insufficient snowfall can threaten entire populations. Snow becomes a partner in their life cycle, a seasonal necessity rather than a passing inconvenience. Yet snow's protective nature extends beyond warmth and shelter. It shapes water in ways that sustain ecosystems long after winter ends. Snow stores moisture slowly and steadily, releasing it during gradual spring thaws. This slow release feeds rivers, fills reservoirs, and replenishes groundwater. Without this steady melting, many regions would face sudden floods or seasonal droughts. Snow functions as nature's reservoir, gathering water in the quiet of winter and distributing it gently through spring. Even when it seems inert, snow is preparing for seasons yet to come. There are moments in winter when snow seems to hush the entire world. Sounds soften, light scatters, edges blur. This quieting effect is not just an atmosphere of peace, but a physical phenomenon. Fresh snow absorbs sound, dampening vibration with the same trapped air that insulates warmth. For animals beneath its surface, this quiet creates safety. For humans standing above, it creates a sensation of calm. The world feels closer, more intimate, as if wrapped in its own soft breath. Snow protects, but it also reveals. Tracks in fresh snow tell the stories of animals that moved through the night, stories invisible on bare ground. The forest becomes a record of passage. Rabbits weave looping paths. Foxes leave straight, purposeful trails. Birds imprint delicate patterns that disappear with the next storm. Snow does not merely preserve life. It shows us where life has been, and perhaps that is snow's greatest contradiction. It embodies cold, yet shelters warmth. It conceals life, yet traces its presence. It halts motion, yet preserves possibility. Winter may seem harsh at first glance, but beneath the surface of snow lies a world protected, supported, and quietly thriving. Snow is not simply frozen water. It is a sculptor of warmth, a guardian of the small, a reservoir for future seasons, and a blanket under which life retreats only to rise again. Ice caves form in places where winter's touch lingers long after the surface begins to thaw. They are shaped in glacier bellies, beneath frozen rivers, or within cliffs carved by storms and meltwater. From the outside, many look like nothing more than dark openings in a world of white. But step inside, even a few paces, and the landscape changes completely. Light bends, shadows curve, the air cools with a sudden purity that feels ancient. Then the blue appears, not in a single shade, but in a spectrum that deepens as you journey deeper, shifting from pale, misty tones near the entrance to deep sapphire and luminous turquoise in the heart of the cave. It feels less like stepping underground and more like passing into the interior of a frozen wave. The blue comes from the ice itself. Over centuries, layers of snow compress under the weight of their own accumulation. Air escapes. Crystals fuse into dense formations that absorb all colors of light except the bluest wavelengths. When sunlight filters through the thick ice overhead, it becomes transformed. What remains is a glow that seems to emanate from the walls, floors, and ceilings. The light does not simply shine on the cave. It fills it. It saturates every surface, turning the space into a cathedral sculpted entirely by temperature and time. The deeper the ice, the richer the color, until the world becomes a realm of radiant blue, quiet and strange and breathtaking. Inside these caves, time seems to move differently. Drips fall from the ceiling in slow rhythms that echo softly through the chamber. Thin sheets of meltwater slide down the walls, reflecting light in shifting streaks. In some caves, the ice is carved into sweeping arches shaped by the glacier's movement. In others, the ceiling hangs low, rippled like the underside of a frozen ocean. The walls often hold bubbles and fractures from centuries past, tiny imperfections that create patterns like constellations. Each bubble is a pocket of ancient air, trapped from seasons no one remembers. Each layered band in the ice is a page from a frozen document, recording storms, droughts, and winters long vanished. As you walk deeper, the cave's architecture becomes more intricate. Meltwater streams carve tunnels that twist in unexpected directions, smoothing the ice into glossy surfaces that reflect the blue glow like liquid glass. Some passages widen into chambers tall enough to feel like great halls. Others narrow into slender corridors, where the walls curve inward so tightly that they seem to breathe around you. Every turn reveals new arrangements of ice formations. Columns rise where water froze in place, their surfaces etched with delicate rings. Thin curtains of ice hang like draped fabric, translucent and shimmering when touched by the faintest glimmer of light. There are moments inside these caves when the light shifts suddenly, not because the cave has changed, but because a breeze has passed over the glacier surface far above, altering the angle of sunlight. The walls respond instantly, shifting from pale blue to deep indigo or from turquoise to silver. The cave seems alive, pulsing with color as though reacting to unseen rhythms. Sometimes the glow becomes so intense that it feels as though the ice itself is illuminated from within by hidden lanterns. Other times, it fades to a whisper of blue, leaving only faint reflections to guide your steps. In many ice caves, the floor is not solid ice but a mixture of frozen sediment and flowing meltwater. The water may run in narrow channels that sing softly as they move, carrying with them tiny grains of rock ground down by the glacier's weight. These grains sparkle when they catch the blue light, creating pinpoints of brightness that drift downstream like stars carried by a river. In the quiet of the cave, the sound of this water feels amplified, each ripple and trickle resonant against the frozen walls. Some caves hold ancient ice that has remained frozen for thousands of years. In these deeper chambers, the air feels denser, infused with the cold breath of ages. The surfaces hold layers of compressed snow that fell before recorded history. Standing there, surrounded by ice older than civilizations, the sense of time stretches and folds. The cave is not just a place, but a record, storing the memory of countless seasons. You can feel that history in the stillness. It is a silence unlike any other, deeper than the quiet of snowfall, shaped by years trapped within the glacier's slow journey. Despite their beauty, ice caves are always in motion. Glaciers shift. Meltwater cuts new paths. The very structures that create the cave also threaten to erase it. A chamber that glows brightly one year may collapse the next. A corridor illuminated by blue light may narrow or vanish entirely. Ice caves exist in a delicate balance between creation and destruction, their architecture constantly rewritten by temperature and flow. Even as they appear timeless, they are never truly fixed. They are living spaces sculpted by melting and refreezing, expanding and contracting in cycles beyond human pace. In winter, when temperatures remain low, the caves become more stable. Their surfaces harden, their colors sharpen. Icicles form in long rows that clink gently when disturbed by shifting air. The cold preserves every contour, holding the architecture steady. But even then, the glacier continues to move beneath its own weight, pressing ice forward as quietly as a whisper. The cave may deepen, stretch, or tilt without any visible sign, its transformations occurring in increments too small to notice. Entering an ice cave means stepping into a landscape shaped by forces both delicate and immense. Light refracts through dense ice with painterly softness, while the glacier itself exerts a crushing, unyielding power. The contrast creates a world that feels both fragile and colossal. You stand in chambers carved by water that once roared and trickled, lit by sunlight filtered through ages of frozen storms. Every sound is softened. Every color is transformed. Every surface feels like the threshold of a deeper mystery. When you finally return to the outside world, the brightness seems sharper, the air warmer, the ground louder beneath your feet. The memory of the cave lingers, its blue depths echoing behind your eyes. In that glow is the reminder that winter shapes not only the landscapes above ground, but hidden worlds within ice, sculpting architecture that rivals anything crafted by human hands. Each cave becomes a temporary masterpiece, glowing quietly in the cold, waiting for anyone willing to step inside and witness its ancient, luminous heart. Every winter, as temperatures fall and daylight thins, a quiet rearrangement begins across the world. It is not announced with fanfare or visible crowds. Instead, it unfolds through the silent pulse of instinct, drawing birds, mammals, insects, and even ocean dwellers into motion. They begin to travel, not by choice, but by ancient design, following routes older than human memory. To watch a winter migration from afar is to witness a vast hidden symmetry, a choreography written in wind patterns, magnetic fields, and the rhythms of Earth itself. While the land settles under frost and stillness, the skies and seas come alive with purposeful movement. Life, unwilling to surrender to the cold, finds its own pathways through the season. The most familiar travelers are the birds that trace enormous arcs across continents, navigating by stars, sunlight, and magnetic cues that operate like an internal compass. In autumn, when the air sharpens, millions of them rise from forests, coastlines, and wetlands. Some travel only a little way, slipping southward by a few hundred miles. Others embark on astonishing journeys. A small sandpiper weighing less than an apple can cross entire oceans without stopping, riding winds that lift and carry it through nights of shimmering stars and cold dawns that unfold into distant continents. Arctic terns go even farther, leaving the top of the world to fly toward the bottom, then returning again in a loop that spans the planet. They spend more time in daylight than any other creature, chasing summer across hemispheres while winter trails behind them. The precision of these routes is remarkable. Birds often return to the exact patch of shoreline or meadow they visited the year before, guided by memories stored in fragile neurons. Even fledglings, who have never flown the route, somehow know the direction and the timing. Their flight lines weave together in the sky, creating streams of motion that pass overhead like invisible rivers of life. When they move at dusk, you can sometimes hear their soft call notes drifting down through the cold air, traveling far in the quiet of winter nights. These sounds carry the weight of instinct, fragile but unwavering. Not all migrations happen in the air. Some unfold across frozen ground or beneath the surface of snow. Caribou travel in immense herds, pushed forward by hunger, followed by wolves that depend on their movement. These herds march across tundra plains, where winter strips the landscape of everything except wind. Hooves crack across ice, stirring echoes that fade beneath the rising Arctic night. Their journey may cover hundreds of miles, tracing routes that shift with each generation, yet always circling back to calving grounds where the next wave of travelers will one day take its place. The herd becomes a living ribbon stretching across the frozen earth, flickering with breath, vapor, and the glint of frost. Other migrations unfold in miniature. Butterflies, impossibly delicate against winter's cold, vanish from temperate fields and forests as frost approaches. Their descendants, many generations removed by the time the cycle completes, find their way back to the very same groves their ancestors once left behind. Monarch butterflies drift toward warm valleys where millions gather in clusters that weigh down branches like living leaves. Their vibrant wings remain still in the cool morning light, then tremble awake as the sun rises and warms the air. The migration continues, propelled not by a single life, but by a chain of lives linked together through fragile inheritance. Some creatures move not across land or sky, but through icy waters far deeper than sunlight can reach. Whales migrate beneath winter seas, following temperature shifts and the dense abundance of food that gathers in certain regions. Gray whales travel from Arctic feeding grounds to warmer waters where new calves are born. Their migration spans thousands of miles, a journey guided by memory and pressure currents shaped by the slow roll of the ocean. Beneath them swim schools of fish that shift their routes with the season, seeking pockets of warmth or following the plankton blooms that pulse through winter waters like drifting constellations. There are migrations so subtle that humans did not discover them until recently. Tiny marine creatures, some no larger than grains of rice, move vertically through the water column each night, rising toward the surface to feed and retreating again at dawn. In winter, these movements deepen, adjusting to temperature and food availability in patterns that form the largest daily migration on Earth. Billions of bodies drift upward and downward like a silent tide, guided not by continents or seasons, but by light levels and atmospheric shifts that ripple through the ocean's skin. Even species that seem still in winter may be on their own quiet migration. Foxes travel across snowfields in search of prey, navigating by smell and memory. Wolves roam across territories expanded by the scarcity of food. Bears, though living in dens, migrate through time rather than space, entering a suspended state where heartbeats slow and warmth is preserved. Their bodies become winter travelers of a different kind, journeying through a season of darkness without ever leaving their sheltered chambers. Migration is not only movement, it is survival written into the bones of countless species. It shapes ecosystems, carrying seeds, nutrients, and energy across vast distances. It binds continents through invisible exchanges as birds drop berries along their roots. Whales fertilize oceans with their wake, and insects pollinate flowers in far-off regions. Without migration, entire landscapes would falter. Winter creates challenges, but it also creates motion that sustains life far beyond the cold months. Yet winter migrations are changing. Warming patterns shift wind routes and disrupt ancient signals. Ice melts earlier in the season, shortening feeding windows for Arctic animals. Some species begin to shorten their journeys. Others extend them. The rhythms carved into instinct for thousands of years now strain against new patterns in climate and habitat. Still, the instinct persists, guiding creatures north and south, upward and downward, across distances that defy imagination. The migrations continue, even as winter itself slowly transforms. To witness a migration is to see winter's influence unfold, not in stillness, but in motion. While snow blankets forests and ice locks rivers in silence, life lifts and travels, following memory and magnetism through vast and shifting landscapes. These travelers carry winter within them, shaped by its cold, compelled by its scarcity, and guided by its timeless pull. Their journeys reveal a season not defined by stillness, but by the quiet determination of life in motion, tracing ancient paths across a world touched by frost. When you step onto a frozen surface, it seems simple at first glance, a hard sheet of cold that glints beneath winter light. Yet, the physics behind that slipperiness, the quiet trickery that makes ice behave like nothing else you walk on, is a web of forces and structures that shift with temperature, pressure, and motion. Ice does not merely sit beneath your feet, it responds to you, altering itself in ways too small to see, creating a thin boundary between solid and liquid that turns a calm surface into a place where balance becomes a negotiation. That thinness, that nearly invisible film, is where the mystery of slip begins. Water is unusual long before it freezes. As temperatures fall, the molecules slow and arrange themselves into a lattice, locking together in a pattern that spreads into crystalline order. But on the surface of ice, the molecules behave differently. They vibrate more than those deeper within the structure, unable to settle into a perfect grid. Because of this restless layer, even at temperatures colder than one might expect, a microscopic film of quasi-liquid water forms on the surface. It is only a few molecules thick, but it is enough to change your footing, enough to blur the line between solid and liquid so completely that your steps slide unpredictably. Pressure adds another layer to this quiet transformation. When your foot presses onto the ice, it compresses the surface and forces the molecules to shift into a state much like melting. Even at temperatures below the usual freezing point, the pressure from a skate blade or a boot can create a temporary smear of water beneath it. This water is not warm. It is simply rearranged, transformed by force into a slippery cushion that forms and disappears as quickly as your weight shifts. In that fleeting layer, friction falls, and motion becomes fluid. It is this effect that makes ice skating possible, letting people glide across frozen lakes as if gravity itself has loosened its grip. Yet slipperiness is not constant across all ice. Temperature plays a role that is both subtle and enormous. Around temperatures close to freezing, the surface film grows thicker and more responsive, making ice at these conditions particularly treacherous. But when the air sinks far below freezing, the molecules become more rigid. The surface film thins. The pressure needed to create meltwater increases. Ice at these colder temperatures can feel grippier underfoot, though still unpredictable. It is a reminder that slipperiness is not a fixed property, but a shifting conversation between cold, pressure, and the delicate arrangement of molecules that reshapes itself every moment. Other frozen surfaces behave differently still. Consider lake ice that has been swept by wind until it becomes polished, smooth, a mirror that reflects the sky with such clarity that it seems to have no texture at all. Here, the slippery film develops evenly across a wide expanse, allowing gusts of air to slide uninterrupted over the surface. When you stand on such ice, you can sometimes feel the faint tremble of distant cracks, vibrations traveling beneath your feet like whispers through glass. This kind of ice is almost unnervingly frictionless. It offers nothing to anchor your step except air and balance. Snow, when compressed by cold or thawing cycles, can take on a different character. It can transform into a surface called néve, where grains fuse together under pressure but still retain enough irregularity to grip. When snow melts slightly under the sun and refreezes at night, it forms crusts that glitter in the morning light. These crusts can hold your weight on a cold dawn, then collapse hours later as temperatures rise. The boundary between ice and snow becomes a mosaic of textures that shift with the smallest changes. Within those shifts lie the physics that determine whether a footstep is sure or slipping. There are stranger surfaces too, ones that form under rare conditions. Rime ice grows on trees and wires during foggy winter nights when supercooled droplets cling and freeze instantly. Its surface is rough, almost feather-like, offering friction in some directions and surprising slickness in others. Hoarfrost forms delicate spikes that crumble under touch, crunching beneath your steps as if you were walking on fragile glass beads. On frozen rivers, pressure ridges rise where sheets of ice collide, creating jagged formations that appear chaotic but follow the hidden mechanics of stress and release beneath the water. Each type of ice carries its own laws of movement, its own relationship with slipperiness. Then there is black ice, the winter surface that hides in plain sight. It forms when rain or melting snow refreezes as a perfectly smooth, nearly invisible glaze on pavement. Unlike natural lake ice, black ice often lacks texture altogether. Its molecules settle into an uninterrupted sheet that reflects almost no light. In this transparency, danger lies not in thickness but in perfection. Without the scattering effects of snow crystals or the micro-texture of natural ice, black ice becomes one of the most frictionless surfaces found in everyday life. A shallow angle of sunlight might reveal it, but often it stays unseen until a foot or tire crosses it and motion disappears into uncontrolled glide. Slipperiness also emerges from tiny interactions between your own movement and the frozen world beneath you. As you walk, your foot wants to push backward. Normally, friction opposes that push, allowing you to move forward. But on ice, the force creates meltwater that lowers resistance. Your push becomes a slide, your balance shifts, and gravity reassumes command. In these moments, walking becomes a quiet physics problem played out in real time. Each step is a calculation, each correction a negotiation between confidence and caution. The slipperiness is not just beneath you, but within the shifting relationship between force, temperature, and timing. Even when the surface seems solid and predictable, ice carries hidden energy. Frozen ponds groan and crack as temperatures drop, releasing tension that is built within the crystalline structure. These cracks can race across the surface like lightning, producing booms that echo across winter landscapes. Yet these sounds do not mean the ice is failing. They often signal that it is strengthening, redistributing stress in ways that reinforce its structure. Slipperiness and strength coexist here, intertwined through forces too small to observe but unmistakable in their effects. As winter deepens, ice shows itself to be not an inert material but a responsive one, shifting with every passing moment. It behaves like a solid, yet carries the ghost of liquid behavior in its surface layer. It holds weight, yet yields to pressure in ways that feel almost alive. To walk on ice is to step into a world where physics feels softened, where motion becomes something separate from intention, and where even stillness carries the potential for sudden glide. In the quiet of winter, ice reveals the delicate balance between order and motion. Its slipperiness is not a flaw but a consequence of its elegance, a result of molecules aligned so perfectly that they nearly return to fluidity. Every frozen surface tells a story of how the world changes when water slows, organizes, and freezes into a form that seems solid yet remains forever close to yielding. It is the season's reminder that even in its coldest state, the world is still in motion, shaped by forces both seen and unseen beneath the surface of ice. In the coldest corners of winter, far from the shelter of forests and fields, the sea itself becomes a kind of frozen garden. When the air is bitter enough and the wind briefly rests, delicate structures emerge on the surface of new sea ice, rising in clusters that resemble blossoms made of glass. These frost flowers are not flowers in any familiar sense, yet their beauty is unmistakable. They appear softly at first, then multiply across the ice as if drawn up from the deep. Their petals shimmer beneath low sunlight, catching shades of lavender, silver, and pale blue. To look at them is to witness something impossibly fragile blooming in a place where almost nothing is meant to survive. Frost flowers form only when conditions align with rare precision. The sea must be in the early stages of freezing, covered by a thin sheet of ice that still allows vapor to escape from the warmer water below. The air above must be far colder, creating a sharp gradient between the surface and the atmosphere. This contrast drives moisture upward in invisible currents, where it encounters the frigid air and crystallizes instantly. Instead of settling as hoarfrost, the ice grows outward from tiny points, branching into feathery shapes. Each crystal becomes an anchor for more ice vapor to cling to. Slowly, the structures expand into intricate forests, rising several centimeters above the surface in a landscape that resembles a frozen coral reef. Though they appear still and silent, frost flowers are in constant exchange with the world around them. They absorb moisture from the air, grow, collapse, and form again in a cycle orchestrated by temperature and humidity. When the sun rises, even weak winter light can cause them to sublimate, shrinking into faint outlines before disappearing entirely. When the temperature drops again at dusk, new flowers take their place, blooming across the ice with renewed complexity. To witness their formation is to watch winter breathe, exhaling crystals into a world that is otherwise empty and motionless. The chemistry within frost flowers is surprisingly rich. As they grow, they concentrate salts and other substances from the underlying seawater. While sea ice itself excludes most impurities during formation, the thin brine that collects between ice crystals can wick upward into the flowers. As it evaporates, it leaves behind concentrated pockets of salt, minerals, and even microbial life. These flowers become unexpected reservoirs of chemistry, holding within their delicate forms clues about the ocean beneath. Scientists study them not only for their beauty, but for their ability to reveal what is happening in the waters that feed them. Within their crystalline structures, frost flowers harbor tiny communities of microorganisms. These microbes, carried upward with sea spray and brine, may find temporary refuge in the ice lattice. Some remain dormant within the extreme cold, while others continue slow metabolic processes, altering the chemical composition of the surrounding brine. Their presence is a quiet reminder that life can persist almost anywhere, even on the surface of a frozen ocean where temperatures plunge far below what seems hospitable. The flowers become microhabitats, places where life and ice intertwine in ways that challenge our understanding of survival. The salinity of frost flowers affects the atmosphere as well. As the brine evaporates, it releases compounds into the air that can influence cloud formation and even the chemistry of the polar atmosphere. Under certain conditions, the halogens within the flowers can react with sunlight to help break down ozone near the surface. This interaction between sea ice, frost flowers, and the atmosphere creates a feedback loop that shapes the winter environment in subtle but significant ways. A single fragile blossom of ice becomes part of a much larger system that affects weather patterns and atmospheric clarity. The flowers also signal the age of the ice beneath them. They form only on young sea ice because the temperature gradient between ocean and air is strongest in the days immediately after the ice sheet forms. As the ice thickens, It insulates the water below, reducing vapor flow. Older ice rarely supports frost flower growth, and when storms sweep across the surface, the flowers are easily destroyed. Scientists use their presence as an indicator of new ice formation, a clue to understanding the changing patterns of polar seas as warming temperatures alter the timing and extent of winter ice. Walking near a field of frost flowers, if the ice is stable enough to allow it, feels like entering a world defined by silence and fragile architecture. Each cluster rises like a miniature grove of frozen trees, their branches so fine that even the slightest breath can damage them. The crunch beneath your feet, if you dare to step nearby, is not the sound of breaking ice, but the collapse of countless delicate structures. They are as temporary as morning dew, yet far more elaborate, shaped entirely by the physics of cold and the lingering warmth of the ocean. When winds return, the flowers vanish quickly, swept into drifting clouds of ice crystals that shimmer briefly in the air before settling onto the surface or being carried away. Their disappearance feels sudden, almost theatrical, as if the sea were reclaiming the beauty it allowed only for a moment. The ice remains, bare and pale, waiting for the next calm night when conditions might once again align for frost flowers to bloom. Their cycles become a heartbeat of the polar winter, a rhythm of creation and dissolution that plays out across vast expanses of frozen ocean. There is a quiet poetry in the way frost flowers mark the boundary between sea and sky. They grow in a place where water becomes solid, where vapor becomes crystal, and where the cold sculpts intricate art from nothing more than breath and silence. They remind us that winter is not only a season of stillness, but one of subtle transformation. Even in the harshest environments, beauty finds a way to rise, delicate and fleeting, offering a glimpse into the deep workings of a world shaped by cold. Frost flowers bloom not despite winter's severity, but because of it, revealing the hidden elegance of a season often misunderstood as barren. Long before cities rose or forests spread in their familiar shapes, long before humans learned to track the seasons with calendars and stories, winter ruled the earth in ways that would be unrecognizable to us now. Ice stretched across continents, carving mountains into new forms, grinding ancient stone into fine dust, and reshaping valleys into curved basins where lakes would one day rest. These winters did not come as single seasons, but as eras, long, deep breaths of the planet when cold was the steady state, and warmth returned only in brief interludes. The traces of those ages still linger around us, hidden in landscapes, buried in sediments, and locked within the walls of glaciers that remain from a time when ice shaped nearly everything it touched. During the height of an ice age, massive sheets of ice covered vast portions of the northern hemisphere. Some were thousands of meters thick, so heavy that they pressed the crust of the earth downward, reshaping the land beneath. As these colossal glaciers moved, they carved wide U-shaped valleys through once narrow mountain passes, scoured plains into smoother forms, and left behind ridges of rock and gravel known as moraines. These features remain visible today, long after the ice that made them has disappeared. When you walk through a valley carved by an ancient glacier, you are moving through a memory of cold that has lasted for tens of thousands of years. The world's lakes and rivers also whisper stories from these ancient winters. Many lakes in northern regions exist because glaciers once gouged deep basins into the ground. When the ice melted, these basins filled with water, creating the freshwater bodies we now see shimmering beneath summer light. Some rivers follow paths laid out by meltwater channels that once raced beneath the ice like hidden highways. Their meandering curves and widening banks echo the pulse and retreat of the glaciers that shaped them. Ice ages changed not only land, but life. Animals adapted in extraordinary ways, growing thick coats, migrating to new regions, or shrinking in size to conserve energy. Mammoths and woolly rhinos roamed across steppes that stretched for thousands of miles, grazing on hardy grasses that survived the bitter cold. Cave lions hunted in the long shadows of ice frontiers, and giant sloths wandered southern continents untouched by frost. Even early humans altered their behavior in response to the relentless winters, learning to craft shelter, harness fire, and follow herds across frozen ground. Entire cultures emerged and vanished as the climate shifted, each shaped by the conditions of the time. When the planet warmed and the ice began to retreat, the change was powerful but slow. Glaciers melted over thousands of years, releasing immense floods of water that carved new valleys and reshaped coastlines. Sea levels rose, swallowing land bridges that once connected continents. These rising waters isolated species, separated populations, and encouraged evolutionary branches that would never have split otherwise. The melting of the ice ages wrote new rules for life on Earth, determining where animals could roam, where plants could take root, and where humans could begin to settle. Evidence of these ancient winters lies not only in the ground, but in the ice that still survives. Deep within the cores of modern glaciers and the vast ice sheets of Greenland and Antarctica, tiny bubbles of ancient air remain trapped like time capsules. Scientists drill into the ice, extracting these long columns of frozen history. Inside them, the faint chemical signatures reveal temperatures, atmospheric gases, and even traces of volcanic eruptions from ages long past. The ice becomes a library of winters, each layer a page that records the state of the world at the moment it froze. From these pages, we learn how the planet breathes, warms, and cools across the ages. There were times when winter reached unimaginable extremes. Thousands of years before the most recent ice ages, the Earth may have entered periods known as snowball states, when ice extended nearly from pole to pole. During these events, if they were as complete as some evidence suggests, oceans may have been encased in thick ice, and the planet's surface reflected so much sunlight that it struggled to warm. Yet life persisted even then. Microbial communities survived in pockets of liquid water beneath the ice or near geothermal vents, enduring long global winters that lasted millions of years. Their resilience echoes across time, a reminder that even in the most frozen of worlds, life finds a way to continue. The most recent ice age ended a relatively short time ago. Human ancestors watched glaciers retreat, revealing new landscapes step by step. Forests spread across once barren plains, rivers settled into stable courses. Animals adapted once more, some thriving in the warmer climate, others disappearing. As the ice withdrew, it left behind fertile soils ground from stone, soils that would someday support human agriculture and allow civilizations to flourish. The very ground beneath many cities is shaped by the remnants of these long winters. Ancient winters still influence the climate we experience today. The tilt of the Earth, the shape of its orbit, and the wobble of its axis all influence the cooling and warming cycles that guide the rhythm of ice ages. These changes happen over tens of thousands of years, too slow for any one generation to witness fully, yet powerful enough to reshape continents. The planet is never fixed in one state. It shifts gently and relentlessly, balancing on forces that move with the patience of time itself. When you see a boulder resting alone in a field, too large for any river to have carried, it may be a glacial, erratic, left behind by ice that vanished long before humans carved stories into stone. When you stand on a cliffside overlooking a wide valley, the shape of the land may carry the imprint of a glacier that once flowed like a frozen river. Even the sand on many beaches is the final product of rocks ground into grains by ancient ice. The marks of winters long gone remain woven into the landscapes we inhabit, quiet evidence of worlds that existed long before memory. These ancient winters remind us that the Earth has known cold far deeper and far longer than the winters we experience now. They show us that change is constant, that landscapes evolve over spans of time too broad to grasp, and that the planet holds its own memory in ice, stone, and soil. Winter today carries echoes of those ages, softened but still present in the patterns of wind, the shapes of mountains, and the slow shifting of seasons. Beneath everything we know lies the trace of ancient ice, a quiet testament to the winters that shaped the world into the form we now call home. Winters were once seen as constants, steady anchors in the rhythm of the year. The cold would arrive, linger, and retreat, a familiar pattern repeated across generations. But the future of winter is no longer something we can take for granted. It is drifting, reshaping itself quietly and steadily, like a season melting into another form. The changes are subtle at first, unfolding in small shifts of timing, depth, and intensity, but together they point to a transformation that will unfold over decades and centuries. Winter is not disappearing, but it is changing in ways that will echo through landscapes, ecosystems, and human lives. Already, the early signs are visible. Snow arrives later in many regions, lingering for fewer days before warmth draws it back into the soil. Lakes that once froze solid each year now remain open through the season, their surfaces reflecting clouds instead of holding skaters or carrying the weight of wind-blown snow. Mountains receive more winter rain and less snow, altering the balance that once fed rivers in the spring. These shifts ripple outward, affecting everything connected to winter's presence. Rivers swell at unexpected times. Forests receive water in different rhythms. Animals adjust migration paths or abandon them entirely, searching for cues that once aligned with predictable cycles. As temperatures rise, the boundary between snow and rain moves northward and upward. Regions that once experienced deep winter now find themselves in a gray zone, where cold and warmth wrestle, creating ice storms, freezing rain, and rapid thaws. This new winter is less consistent, more restless. The freeze-thaw cycles grow sharper, stressing trees, cracking infrastructure, and reshaping the texture of the season itself. The crisp, dry cold that once defined winter nights becomes less common, replaced by a damp chill that seeps rather than bites. Yet change is not uniform. Some regions will see heavier snowfalls in the future, not because the world is cooling, but because warmer air can hold more moisture. When that moisture meets a cold front, it can fall as thick, heavy snow that blankets landscapes with startling intensity. Winters may become shorter overall, but the storms that do arrive may be fiercer, delivering larger amounts of snow in smaller windows of time. The season grows compressed, but in those brief moments, winter asserts itself with a strength that feels almost defiant. Sea ice, one of winter's most defining forms, is disappearing more quickly than many expected. The Arctic transforms before our eyes, trading bright, reflective expanses for darker, open waters that absorb sunlight and accelerate warming. This shift does not only affect the far north, it influences weather patterns across the world, altering jet streams that once carried cold air in reliable arcs. Winters in temperate regions may swing more wildly, shifting between unseasonal warmth and abrupt plunges of cold air released by the destabilized currents above. The season becomes a landscape of contrasts, as unpredictable as it is familiar. Ecology moves with these changes as well. Some species attempt to adapt by shifting their ranges, traveling northward or climbing higher toward cooler habitats. Others rely on cues tied to temperature and daylight that no longer align. Plants bloom too early, exposing themselves to late freezes. Insects remain active deep into autumn, reshaping food webs that depend on seasonal dormancy. Animals that rely on snowfall for camouflage, such as hares and weasels, molt into white coats that no longer match their surroundings, leaving them vulnerable against the darkened winter ground. The subtle choreography that once connected all forms of life to winter's arrival grows disjointed, as if the rhythm of the season has changed and not all dancers can keep pace. Human traditions shift too. Winter sports that once thrived on reliable snow must search for higher altitudes or invest in artificial substitutes. Ice fishing seasons shorten. Festivals timed to the rhythm of cold weather adjust their schedules or retreat into memory. Even the quiet moments that defined winter for so many people, the crunch of snow beneath boots, the sparkle of frost on windows, the silence of a world muted by snowfall, grow rarer in some regions and more precious when they do appear. But winter is not vanishing from the world. It is evolving. In some places, colder extremes may still emerge, fueled by altered air currents or sudden dips of polar air. These events may feel sharper against the backdrop of warming trends, catching communities off guard even as overall temperatures rise. The future of winter is not a simple path toward warmth, but a mosaic of shifting patterns, each influenced by the planet's changing atmosphere. There is room for resilience in this future. Forests adjust their composition over generations, favoring species that can withstand freeze-thaw cycles. Wetlands adapt to new flooding rhythms. Animals migrate, evolve, and seek new habitats. Human communities learn to read the new signals of the season, building systems that respond to unpredictability with flexibility rather than fear. Winter may become different, but different does not always mean diminished. It may arrive in new forms, shaped by forces that have always guided the planet, even as those forces accelerate. The future of winter will carry echoes of its past. Frost will still form on quiet mornings. Snow will still fall in sweeping silences that transform landscapes overnight. Lakes will freeze, though perhaps less often. Light will still catch on ice and turn the world into a mirror. The season will not lose its beauty, but it will express that beauty in new ways, shaped by the changing world beneath and above it. Winter has always been a season of transformation. The future simply holds a different version of that transformation, one that unfolds not just over months, but over decades and centuries. The cold seasons ahead will reveal a world in the midst of change, a world adjusting, shifting, and learning its new rhythms. And even as winter evolves, it will continue to remind us of the delicate balance between warmth and cold, change and continuity, stillness and movement. The season endures, carrying with it the quiet power that has shaped the world across ages, waiting to show us what form it will take next.